Hello, hello. Um, and we are once again going to work on Kast. Today. Oh, well done.
Hello, Veldak.
We're going to improve the JavaScript transpiler today. So, the JavaScript transpiler works. And we are testing it using the advent of code. We already have solutions written for the advent of code 2025. So here's day one. Ran on example on the part 1, the answer is 3, and that is what we get here, right? And just like that, we have all of the days, but not all the days are working yet using the JavaScript. So I fixed a bug, but then there is more stuff to be done. Day 9 is not being transpiled because we are using a feature which I was not using the previous days, specifically this feature, implementing type as a trait, basically. Use Markdown through AI to bash transpiler. Yes. No. So yeah, this is actually implemented, but not exactly. So this is line 100. Implementing a trait, or implementing a cast, this is more general than just the traits, can be done at runtime, but right now I'm only transpiling the ones that are done at compile time, but this should be really easy. Because we already have it. We have the function impl cast. So when we do impl cast, we just give it the value, the target, and the implementation. That's what we need to do. And this literally has value, target, and implementation. A value is expression, target is a value, implementation is expression. So I need to transpile all of those. But this is... yeah, this is as statements, exactly. And that is what it's going to give me. Yeah. So we just say that value is transpile value. Target is transpile value target. No, hold on. Value is expression. And impl is transpile expression impl. So that's all. I'm reading about tools which use Markdown to describe task and then call LLM backend on little command line. I see. Hello, C Films. We're doing great. We're testing advent of code using JavaScript transpiler. So there we go. This is day 9. In day 9 of the advent of code, let's open it fully here. Advent of code day 9. It also is automatically testing, by the way, so if it runs and if it doesn't exit with non-zero exit code, then it means that my answers are correct, because we are asserting that the answers are correct. So so this is run and this is correct already. So day 9 is also working. Is there a day that is not working? We can also check day 9 like part 2 using the actual input, right? Well, it seems like performance-wise, it is still not what it should be. I'm wondering if the performance is because I'm creating a lot of like closures and like invoke them immediately, basically. Does that have performance implications on JavaScript? How much per like overhead is there in JavaScript? My language transpiles to JavaScript. That's the new addition. Yes, we also have interpreter, and then there's the transpiler to JavaScript. There's going to be more targets in the future. JavaScript is just the easiest one to implement. It's going to be compiled to native code at some point. Is there in JavaScript if I create closures and invoke them immediately? Almost none. Unless you're doing it in a hot loop millions of times. Well, yes, that's what I'm doing. I'm doing it in a hot loop millions of times. Hello, Nigel. No captured variables. The overhead is basically like the function allocation is still happening, right? Engines often inline this entirely. If there are captured like this captures variables, right? Now there is a scope object, but it's tiny, short-lived. Previously, at least to allocate it or optimize the way. Like, it depends if it can optimize it or not, right? We can try to improve it though. This over here is still running, but it's all supposed to run really, really quickly. Unless maybe my implementation is wrong. This is what? This was day 10? No, this is day 9. Drawing edges. Yeah, this is day 9. I don't remember what was happening in day 9 of the advent of code. But there is something. Oh, day 9 is where we have like this this shape. And we need to like find the rectangle with the biggest area. Well, but it runs still faster than my interpreter. That's what matters. All right, day 9, day 10. Day 10 doesn't compile. Let's see what's happening in day 10. We are missing line 486. Assigning to a tuple. Okay, so in day 10, apparently I'm assigning to a tuple. Maybe because I'm swapping or something. Yeah, we have swap, literally. Right? So we are doing this thing. Okay. Alright, we just need to make sure that I can assign to a tuple. expression. So we are just going to say tuple parts it's similar to pattern matching a tuple. Okay, I think that's all. We can. I don't implement the unpacked yet. Tuples, but that's fine. All right. Well, we have an error. Throw error. Oh, no JavaScript branch over here in the operators. Bit shifting, because we use the bit operators. Okay, we just implement the bit operators in JavaScript, right? How do we do this? Bit operators in JavaScript. Do you just literally have this? And then you have the triple right, zero fill right shift. JavaScript uses 32 bits bitwise operands. JavaScript stores numbers as 64-bit floating point numbers, but all bitwise operations are performed on 32-bit binary numbers. Hello, Penguin. How would we do this thing for a 64-bit? Let's also have the reminder. This also is implemented in the like this rem, I guess. Bit and bit or bit XOR bit not.
Hello, Pgorly.
Hello, Pgorly. Bit shift left, bit shift right. Okay, let's implement all of those. Runtime TS, yes. Wait, you do a semicolon over here? Don't you do a comma here? Or is that the same thing in JavaScript? Oh, this is a type definition here. It converts this into a semicolon automatically in the type definition. Okay, I guess both work there. Okay, rem, and then bit operators. bit and... I mean, let's just do this. It's just not going to work for the 64-bit ones. But... bit or... bit store... bit shift left... and shift right... and bit not, which just has a single X like this. And this is just going to work, I guess. No, there's something else. No branch in std. Oh wait, hold on. We have the exit. Low tangible. Why do I use the exit? std exit. In the advent of code here. Day 10. Sys exit. Exit. For some reason. Oh wait, expected 7 got 12. It's because yeah. The exit one is in the common KS over here. When I'm asserting the answer, I actually got the different answer, right? So my test failed. We compiled, we ran the program, but this thing said that we have a different result than expected. All right. Why is that? Is that because I actually need the bit operators for 64-bit integers here? It's a BFS. I don't remember what day 10 was about. It's a 32-bit integer here. So... And the bit operations are only in the part... Oh, is this the one where... Yeah, this is the one when we do the Gaussian elimination. That's right. Solve part 1. We in the part 1 though, we just do the BFS. So the BFS does not work here. Bit XOR state. This is a 32-bit. What am I making? I'm making a programming language. This is the solution of the advent of code in my programming language. But I was using the interpreter to solve the advent of code, and we have recently added the JavaScript backend. We are transpiling the language to JavaScript, and now I'm just testing that the transpiler is correct by using the advent of code as a test, basically. Right. So yeah, it says expected 7, but we got 12. Max voltage 12. So I can run this without targeting JavaScript like this. This is just going to run the interpreter. it's really slow, especially after some of the additions. That I added recently. I'm not even sure that I can like see it finish anymore. So my only choice is to use the JavaScript now, or improve the interpreter. I need to like remember what this was about. Advent of Code. Day 10. We have like a mask here, and everything like this is another mask. I mean, I would expect that I just did a bug in this code that I just wrote, right? So bit shift left is this, bit shift right is this. Is that what it looks, what it should be? Bit XOR, bit OR, bit AND. Let's just, you know what? Let's just go into test, and let's just run this. Use std prelude. And then with dbg print, let's do this. One std op bit shift left 1 2. So this is 4. 4 is correct number, right? And there is not a lot, like this is not big numbers, for sure. Bit shift right, 7 by 1. Is Lua beginner friendly? Yeah, sure. It is, I guess. What are you trying to... What is your goal? Why are you learning programming? Because I would suggest going just with the most popular language, which is JavaScript. Lua is nice if you want to, like, it's used in modding, for example, right? If you want to write something for... Is Roblox using Lua? I think it is, right? So, like, if you want to do something for Roblox, then you would need to use Lua anyway. Bit, maybe bit not 7. What should it even be? -8? Python? No. I mean, I guess it is -8. I don't know. Okay, let's then okay, so it doesn't work on the example here. we expect 7. But it prints 12, right? Okay. Let's look at the code here. So we're doing the solve part 1, bit shift left, machine lights, pushback, Q push. DBG print state. Yeah, how about that? We're going to print the state every time we do the BFS, right? There you go. Well, I mean, this is just some numbers, I guess. But we start at 0. Hold on, is starting at 0 correct? Hold on. Let me remember what this was about. To start a machine, its indicator lights must match those shown in the diagram. Okay, I think we start with everything turned off, and then we need to turn the lights on where the hashtags are. And then we have a bunch of buttons here, right? So the first button is just toggling the light at index 3, so the last light. This one is toggling light number 1 and number 3. This one is toggling number 2, this one is toggling 2 and 3. So we can, like, every button is switching multiple lights specified, and then we need to find the fuse turtle presses required to correctly configure everything. Yeah, makes sense. So maybe I can print something. You know, we have the new state here. A new state D is 0. So this means that I have not visited this one yet. So I can debug it here, you know. We can dbg print. Wait, new state. Wait, hold on. What is this? We have direction. State D less than 0. Then negative. Oh wait, hold on. I'm doing the BFS from both ends here. Right, I'm doing BFS from both ends, so it's a little bit more. Okay. Let's just dbg print anyway. So we dbg print state, direction, new state, and then changes. Just like this. Classical versus C, different types of suffering. Yeah. Hello, Jikwons. Okay, this over here. We start at 0. So 0 is our original state. We go in the positive direction. Yeah. Yeah. New state is 8 because changes are 8. Okay. Can I get the index of the things? List iter. Do we have iter I? No, we don't have iter I. But we do have iterable enumerate. Okay. What about if we do this here? std iter enumerate. So then we'll have index and changes. This must be in parentheses. Can I make it so that this does not require parentheses? I need to like move around some priorities. Like the index of the button, you know? Button is I. You know? Yeah. So we can like see what's happening here. Basically, we go button number 0, right? Starting from 0. So we start with empty one. Button number 0 is having is toggling the light number 3. Light number 3 is bit mask, which is equal to 8. So that's why it is this. Sure, that's our new state. Then from 0, using button 1 is 10. Button 1 is 10 because it's 1 and 3. It is 10, yes. Hello, Death Razor. Button 2 is 2, which is just 4. Button 3 is 2 and 3, which is 4 and 8, which is 12, right? Yes. And this one is 0 and 2, which is 5. Yes. So, yeah, and then the last button is 0 and 1, which is 3. Yes, so like the buttons are encoded properly. So then why? Oh, wait, hold on. There are different machines, right? There is like, because we are doing the fuse total presses for all of the machines, right? Yeah, we can like debug which one is not correct. You know, machine answer. Machine answer. Yeah, this is solving for a machine. Let's do that. No, this doesn't work. A number literally inferred as unit. Oh yeah, because the semicolon does not need to be here anymore. You're leaving Rust again, need to do interior mutability that doesn't make a stack value. You need a way to do interior mutability that doesn't make a stack value. What does it even mean? Mutex guard ref mat. I mean, yeah, okay, I see, I understand. But you just drop it immediately. You need a mutable reference from a mut. Well, you just hold onto the original mutex or to the original ref cell. That's literally what you do, right? Toolbox. Activate your Linux. I refuse, guys. I refuse. We leave pirate life here. Why not? And not we never activate our Linux. Activating Linux is a sin. If you ever did that, toolbox. Activate or else. What are you guys doing on your stream? Hello, welcome everyone. I'm working on my programming language. I am transpiling to JavaScript, and I'm testing that it works correctly by using my Advent of Code solutions. You're making a game? Nice. We like games. Eventually I will be making games too. Eventually. Thank you for the gift sub, Medusa. All right. So right now, my Advent of Code solutions were correct, and the JavaScript transpiler is the new thing that I added recently, and the first 9 days of Advent of Code I already tested through the JavaScript transpiler, and it is correct. And then day 10 is giving me the incorrect answer, so I'm like figuring out why am I not compiling it properly here. You was making a game once, then you got on Twitch. Yeah, that's why you that's why you don't get on Twitch. Or if you get on Twitch, you become a streamer on Twitch, because then you don't get distracted by another streamer, you know, and you actually make some progress. You know. Although you also always risk, instead of making games, to be distracted into something like making your own programming language, you know, and then you never make games again. So yeah. Anonymous gifter gifted Medusa the sub. Thank you. Bum, 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 bum. All right, and I solved Advent of Code. It was a month ago, like exactly a month ago, right? I don't really remember much, but this day 10 part 1 was involving a BFS. I did a BFS from the both ends so that it's faster, because my interpreter was slow when I was doing this. So yeah, we're just figuring the things. So here you go. We just try this again. Run. Okay. Okay, so I'm just doing the example here. So the machine answer for machine number 1 is 4. Let's see if this is even correct. You could press the first 3 buttons, 1 each. At a total of 3 button presses. Okay, so the first machine is already not correct. We are reporting 4, but the answer is 3. Okay, so why is that? Because we need to hit the first 3 buttons, right? So button number this, and that, right? Which is going to have number 1 and number 2 set. That sounds correct. Okay. Did you ever make a game and thought you would make another game, then made a game and another game? Yeah, like so my game over there that I'm working on, Linksider, yeah, we have a demo, and we hopefully will release the Linksider this year. I'm going to start working on it again soon, as soon as my teammates are available. But yeah, this game was originally made for a baby jam, so I was doing a lot of game jams, and there were a couple of times where I thought that I should like turn my game jam game into a full game. I started working on that, and then I participated in another game jam. I made another game, and I thought, okay, well, this game is now like surely better than the previous one. So if you ever think that you have a project that is good and you want to finish it, then finish it and don't start any new projects, I guess. Yeah. So yeah, that's why I have not been doing a lot of game jams recently. Kavina made 7 games in the last 5 months. Yeah. Well, I mean, if you don't have a project, thank you for the gifted sub. If you don't have a project, then game jams are really good to find an idea that will work as a game, right? Because you can have an idea of a game that you want to make, but is that idea actually good? You know? So in order to test that, game jams are really good. Yeah. And game jams are just like a way of giving you early feedback for your game idea in the first 2 days after you have the idea. Yeah. That's like one of the reasons to do the game jam. Another reason is just to try and like learn something, or to just practice, or just have fun with friends, you know. So yeah, I'm making my programming language here. I am compiling to JavaScript, and one of the main reasons I'm choosing JavaScript as my compilation target is so that I can create a game that is going to run on the web, because when you do a game jam, it's very important that your game runs on the web, otherwise no one is going to download a random executable. So yeah, we're slowly getting there. Actually, in fact, I have yesterday did this thing. I have an example. It's not a game yet, but we have this. Localhost 8080. Is it 8080? I need to compile the browser example. There we go. We have a hello world, and then we do, this is done using the canvas API. We draw a house, just like in the tutorial of somewhere. So we're not that far from actually making a game. If anyone asked me advice, I'd be like, do a game jam. I heard a lot of people who are actually not the fan of game jams, and their reasoning is usually like, you basically waste your time. Instead of working on an actual project, you're doing something useless that you're going to throw in the garbage. I heard a lot of people say that. If I click out of the screen to talk with you and then click back, I move, but I want to move with A and D only. Oh, you are trying to play my game? Yeah, maybe we should. The idea for the clicking means movement is because the game is supposed to, like, it's also working on like mobile, so that's the touch control. I mean, sometimes I feel like having a mouse control is good, but maybe this should be toggleable and you should be able to disable it. I don't know. That's a good point, though. But you can just play the game using mouse. Ew, JavaScript. I was lurking, then we raided a channel that I'm a mod of. Nice. Oh, Brainoid. Hello, hello. How's your game? What is Brainoid doing these days? Are you improving the replicate, or are you doing something new now? Back fixing quality of life stuff. Nice. All right, let me just debug a little bit here. I'm trying to see. So machine number 1, we are doing Advent of Code day 10. Advent of Code day 10 debugging. So it says that it's not 4, right? So if I press the first button, then we get the state of 8. If we get, yeah, our target state is 6. So we press the first button, we get 14. Wait a second, this over here is weird, right? So this is BFS from both ends. I only go from the target in a single step here. This seems not correct. I only try to press the first button, not any other button. How goes Kast? Kast has a lot of progress. I'm almost ready to make games, Brainoid. You see this hello world and like as a house drawn on the screen? This is done with Kast. Soon we're going to go back to game jams. But first I will probably go back to Linksider. Also, Gust is going to reply with this message. Yeah. My Twitch bot is also running using Kast. That's right. But that one is running using the interpreter. We can try to make the bot. How many chapters in the demo? There's like 5 chapters. If you try to beat every level that is available in the demo, it's going to take you around an hour, maybe a little longer. Depends on how quick you are with solving puzzles. If you just rush through, it can take about 20 minutes, I guess. Okay, here is my... yeah, we don't even get to the Gauss elimination, right? Solve part 1. This one is the important. BFS beat field sequence. Do you remember Advent of Code Day 10? It's BFS over beat masks, right? Every like edge in the graph is XORing your current state with the like specific button, right? And we're trying to get from 0 to a specific state. You did part 1 but gave up on part 2. Okay, yes. Right now what doesn't work is part 1 though. It was working, but it doesn't work anymore. Because I'm transpiling like into incorrect JavaScript. So I'm not sure why I'm looking at this code here, because that should not matter. Oh wait, is it break here? Hold on. What if... Oh, wait, what if this break... Oh, this is just giving me the machine answer. Oh, wait a second. This break, hold on. This break should break this thing here and not this one. Yes, that makes sense. Because, okay, I remember now. Because we have a history here. Previously, there was like list iterate, which was taking like the list and the function, right? Which takes the item. And then over here, we had the break. So this break was not breaking out of this iteration, but it was breaking out of this loop. And now this break is breaking out of this loop, so we are overwriting the machine answer. So we need to break this one, because this means that I have found the answer. So in order to break from the outer loop, we need to do, you know, like just unwindable here. Unwindable BFS. And then we, instead of break, we say unwind BFS. That makes sense. So it's not the transpiler that's incorrect. The interpreter would not give us the correct answer. Okay, there we go. It's fixed. Nice. Debug printing. Let's remove that. Okay, let's see that this still works for part 2. This from here, part 2. So this is Gaussian elimination. We have out of bounds. Okay, this one also doesn't work. Probably, maybe for the same reason. I don't know. This says free variables, which means that Gaussian elimination has already happened. And then we have out of bounds somewhere. This stack trace is the stack trace for... Wait, hold on. Can I have the stack trace of the original code, though, somehow, when I'm running transpiled JavaScript? Is that possible, even? Can I get a recipe for a quick dinner? No. Can I get a stack trace from original source when running transpiled JavaScript? Source maps. I mean, I do have a source map, right? Node enable source maps, or set node options enable source map. Okay, so stack traces will point back to the original files. Is that right? Is it not lying to me? Let's do node target compiled and then oh, I'm also doing the format. I guess I need to make sure that the formatter doesn't run. Then we do this. Part 2. And we do enable source maps. Okay, hold on. We have something here. We have a panic at T. This is not T, but it is a panic, right? This, okay, that makes sense. At this over here, right? It's like weird names. This is called index for some reason, but this is actually called aesthetic collections trip at. Maybe I can fix that somehow too. So this is from list at, and this is the yeah. This over here is out of bounds. List at mut vars vars. So this is brute forcing after doing the Gaussian elimination. Yeah. Attacks is still from JS. This one? No, this is because we're inside of a for loop. It points to this macro, which is a for loop. There is no JavaScript file except for the object panic, right? Because that is implemented in the runtime. Because panic is just throw s. Yeah. S is the only JavaScript. Everything else is from Kast. So the only like wrong thing here is the names of the functions, but the lines that it's pointing to is actually correct. At X? Where do you see it? I don't see at X anywhere. Oh, X is anything? Oh, because this is called T? No, I don't call. Maybe. I don't know. Yeah, maybe it is from JavaScript. I'm creating anonymous closures everywhere, so I would expect everything to be anonymous, I guess. But if an anonymous closure is assigned to a variable, like a variable T is a closure, then we will see this in this text trace, right? That maybe makes sense. Yeah, maybe. Yeah. That makes sense. Although, why is T a function? That it's not a function. I don't know. Alright, let's see if this code is maybe just not correct. Gauss elimination, brute. It's a module, and I have not tested that this works, maybe. So I'm trying to force. This is brute forcing. This is our current, like, what is the index of the free variable, right? So we have three variables, 3 and 5. Is that correct? Can I run? I think I cannot run, is like the unfortunate thing. Oh, it's doing the part 1 anyway, even if I do part 2, I guess. No, that makes no sense. Why would it say starting BFS? Kast run. Do I need to do a dash dash? Interpreter is too slow. Oh, okay, hold on. There we go. Free variables is 35, max joltage is 7, combinations max 3 is 49. And then we like, yeah, this is how much brute forcing do I need to do, basically. 50 brute force iterations. And that is very slow. Okay, so we are not even getting here. So the free variables are actually figured out properly, right? Yeah. Free variables, max voltages, combinations. Okay, maybe I should have waited. Should I try waiting on my actual interpreter? Let's try waiting. Let's look at the code for now. Maybe I will spot something. So we do out of bounds. This over here, the free variables. But how would this be out of bounds? That makes no sense. Because the free variables, this is a list of indices of the free variables, and we did see that free variables are 3 and 5, which is the correct thing. Wait, is it correct thing? Hold on. So we have a variable for every button here. 1, 2, 3, 4, 5, 6. I mean, yeah. I can, I guess. What I can do is I can get the index here. Free variable. index. Free variable index is this. dbg print free variable index. Yeah, let's do that. Let's keep this running, sure. And then test the JavaScript. Oh wait, hold on, I'm not even getting there. Wait a second. dbg print I list free length is list length of free variables. Okay, so this is not correct for sure, right? It says that the length of this list basically is 0, and I'm trying to get the thing at the index 1. Okay, that's definitely not correct. So free is this list. Let mode module. Maybe it's because of the way I'm doing the module. Hold on, let's do a test. Let's do a test. Let's do a single test. We say let foo is module, let f be x is equal to 1, let x is equal to 0, and then we dbg print foo x. I guess this must be mutable, right? And then we do dbg print foo x after doing foo f. I have a feeling that this it actually prints 0 twice. Yeah. So this function is capturing x, but foo.x is a different variable, basically. That is why it is wrong, probably. Because when I'm compiling, so a module is a thing which turns every like variable into a field, and is also recursive. So when we transpile this to JavaScript, we basically add in the end this like the anonymous closure, and then we just return an object where x is a field, which is obviously wrong because this x must be the same as this x. Yeah, but I cannot do that like this easily. And to actually change the way I'm compiling it, because I need to like create the object first, and then when I see x, refer to this field directly, I guess. Okay. How difficult would that be? Let's see the transpiler. Okay, I guess I will stop this. Kill. Here we go. We have expression module. We have a module value. So we basically transpile like the definition as is, and then we just return the value which holds the local variables. My god, the nesting. Yeah, I know. Maybe it could be fixed, but I don't really care much right now. We will try to do better code when we rewrite the language in itself, right? Right? Surely the code that is written in Kast is going to be perfect. So this is wrong. I instead need to say that these bindings when we see them in the inner code are referring to the fields of my objects, right? Yes, and we don't even do a let pattern match. I guess I mean, so what we can do, we can actually create an object with no fields first, and then we can add the fields as we go, because we are in JavaScript. We don't even need to initialize anything here. So we're just going to say something like this. We'll generate the code like this. Let like module value be equal to empty object, and then every time we see the actual like you know, in Kast we see let x be 1 to 3. This is going to be translated into module value dot x is 1 to 3, right? That's what we want, and then we return module value in the end. Because that works with mutation. This, what I had, works if no mutation is happening. Yeah. Let's see. A camel format has profiles, default, a camel format, and Jane Street. Maybe you can try one of them. You think I want to reformat the entire thing? I don't know. I have something here. Break string literals never, break cases top level, and tabular correlation sparse. But yeah, maybe I could like have some other settings there. But this is going to be a deeply nested code anyway. Unless we change something. Like it's mostly like because I'm constructing a bunch of values, right? So I'm constructing an object which has these fields, and the field has a name and a value is a variable, but every JavaScript expression must be annotated with a span, which like is like leading to this. It can still be made to look better. Yeah, maybe, I don't know. I'm kind of used to my code being ugly at this point. I would need to remind me when I commit, and then we can go back to try it at least for a second. Okay, I mean, sure, let's just do a stash, you know? Let's do a stash. And then we will stash pop. Oh, camel format. How do I do it even? I want to use the JString profile. Profile Jane Street. All right. Holy, my entire code was deleted. Wait, it does a double semicolon everywhere now. Hold on a second. So before it was formatted, we had 13 lines of code, and now I have 1,000. So it deleted 300 lines. Is it better? Does it mean that it's better? Oof, this is ugly over here. I mean, I understand why, but this is ugly. Having a leading semicolon. Maybe I can get used to it. Does this look better? What's the difference? Where did all the code go? Like, all the code is just like flat now. Sometimes. Can I just do... Let's undo this first. Git stash pop. Okay, I'll bring this back because we will just do an FMT. It's going to format the entire stuff, right? And then we'll see. Maybe I will try using that. No one is doing the pull requests anyway. No one should. What was I writing anyway? What was I writing? Well, now I got distracted. I don't remember. I was doing something. The module over here, right? So we just say, we say, JSAST let variable be module value variable. Module value variable is generate name module. So value, we're just going to start with an empty object, like I said. So we're going to introduce the module. First, we are introducing the module, then we're transpiling the definition, and then we return, and then what we return is going to be just the variable, which is module value variable. Right, then that's what we just returned. Yep, and we don't need this anymore, but we need to go for all of the bindings, and when we see the binding in the definition of a module, We will need to do something about it, right? Barely implemented tank controls with Raylib. Nice. So when do we see the bindings, right? This is going to happen in pattern matching. So when I'm pattern matching and I have a binding, this binding might be the might be not a new variable, but basically a new field in our module structure. So instead of a let, we would assign to the other thing, right? So we need to see if this binding is what we want. Okay, so let's, I guess I need to store this somewhere in my context, right? And to store it somewhere in my context. So probably mutable module bindings. It is going to be from a binding id map from a binding, a map from a binding into the name of the object. So module of binding. Yeah, that makes sense. Module of binding id map empty. So when we are seeing the module definition like this, we have the module value var. Module, let's just call this module var. So then we just go bindings, iterate. Context, module of binding, id map. We can add sequence, by the way. Add the given bindings to the map in order. Is this not implemented as just... No, this is just implemented as add anyway. So we just context module of binding is adding. So binding ID is going to have the module var associated with it. And that's all. Function binding. And then once again, when we do pattern match, over here, instead of a let, we are going to do something else, right? So we are going to match context context module of binding id find binding id. So if there is if this binding is just a freestanding binding, then we just do this. You like the implicit context struct? Are you talking about Odin to Robert Pattinson? Or are you talking about this? Because I am using this pattern now in my OCaml code, where I have basically an implicit argument to my code, because this code is supposed to be executed in the context, so that I can have all of the these things here, which is very similar. This is not Odin, but Odin also has a context system. In Odin, the context system has a fixed context type. So adding custom data is possible there, but it's completely like, it's like a void star, I guess, there, the custom context. And I'm going to use this a lot in my actual code once we have the context system in the Kast, because I think it reduces the boilerplate a lot. It's really nice. Robot using Odin with Raylib, yeah. How do you like Odin? Boilerplate like what? Like passing the allocator like you are talking about the context allocator there, right? You haven't touched it yet, right? Yeah. So like if you are, Odin is not bad yet. Yet, right? So like in a language like Zig, you are passing the allocator explicitly everywhere, right? But in Odin, the allocator is always available in the implicit context object, which reduces the boilerplate, right? Allocator is just one of the examples of the thing that you would need to pass around explicitly in Zig, resulting in a lot of boilerplate, basically, right? But once you have a lot more context things, right, then passing a lot of those variables is going to require more work. Well, usually you just group those objects into a single struct and then pass that around, but that is also a lot of work. With the proper context system that we are going for, it's going to be like very easy, basically. While writing C, I remember some things I wish C had that Odin apparently has, but I can't remember now. Does Odin has generics? I think Odin also is a very simple language, which probably doesn't have generics either, right? I don't know. Like, Odin's goal, as far as I understand, is to be a really, really simple language. So it's not very far from C. Other than the context parameter, which is implicit, is there anything else that it adds to C? I'm not even sure. Odin does have some level of generics? Okay. Yeah, I don't know much about Odin, I just read about the context there. Mostly. I love there are no includes. Well, you import, right, instead of including, I'm assuming. They just have a proper module system instead of a header file. All right, I'm just trying to do here. If we have a sum, so this thing exists in a module, then some module var, then instead of doing a let, we are going to do something else. We are going to instead say assignee is going to be the field the assignee is going to be a field of the object. Object is going to be the module var itself. and the field is binding name, just like that. Yeah, I guess, and then we either claim the place or we do that. That's the same, yeah. This can be not the copy paste, right? Wait, what? Odin has packages and all the files in one directory is a package, and files in the same directory to each other, fields and methods. So it's basically like Go in that. I didn't like Go's module system. Go's like they also call it packages, right? I didn't like it too much. I don't remember the exact reasoning though. It feels implicit. It's not because it's implicit. There was something else. Like you have the same in like. Do you feel like it's implicit in Camel with Dune here, where we just have all of the files in the directory also? Although they don't have like recursive like dependencies in Camel, right? In Go and in Odin, I guess you can recursively refer to other things in a package. X is not defined. Yeah. So now also when I'm referring to the thing, right? So when I'm blocked value binding, this over here. When I say blocked value binding, it's not always a variable, but it sometimes is a variable which is inside of a module, right? So I'm going to I'm going to match. I'm going to match context module of binding ID map find opt binding. Alright, so if we have some module var, then we are going to, instead of referring to the variable, we are going to say that we're getting a field. Object is var module var, and field is binding name. Binding ID. X is not defined. I'm transpiling test ks, this file, right? X is not defined. Oh wait, hold on. Is it because what? So it says X is not found because this X should basically be like automatically converted to foo.x here. when I'm compiling this. Oh, wait. A second. Module of binding. We add binding ID here. Module var. Can I look into transpiled code? Let's do this. Const int32 is a native int32. We're going to do this without the standard library now. Instead of dbg print, dbg print. LSTD. Yeah, so this is like compiled immediately now, and we can go into compile.js. This is still 500 lines of code though. Well, I mean, it's not 500 lines of code because some of it is half of it, I guess. Is the runtime. So this is dbg print. Oh, there you go. Module x is equal to this, right? Var this is equal to that. So module x is equal to 0, right? That's what's happening here. And this line of code. I feel like I'm going to optimize this later today if we get... if we fix the bug. Well, I need to fix the bug first and then optimize the generated JavaScript. Can Kast run on my microwave yet? Well, Java script is running on billion devices, right? So you probably can. Yeah, so here's our module, and this module has a field X and it has field F. So when I'm introducing them, we are writing to that. And then we have print X, right? Yeah. But then this over here is just, okay, yeah, this over here. This just refers to the original X, which is wrong. Because that's the same binding. So why did I not find this in my map? Unless maybe I need to do something else. Let's see if binding name. So binding name is used in a bunch of places. Oh, because we have place expression binding. Okay, this is the one, right? We have place expression binding, and then I have blocked expression binding. Yeah. Place of this. Place of. Let's just call it transpile binding binding. span is this. That's what I want. And then we have blocked value binding. This should just return transpile binding. I guess span is not in this case. Binding, and this is the transpile binding. Binding, just binding. Okay, is that all? Let's try again. Okay, this works now, and we actually see the correct answer. All right, now let's just run the advent of code, day 10, part 2. Answer is 10. But we have X to string, cannot read properties of undefined, reading to string. Is answer 10 the correct answer for the part 2 on the example? Or maybe like answer is not like the actual answer, I'm not sure. Answer is 10. It's gonna be removed. Answer is brute machine answer. Oh, this is just the machine answer. So for the first machine, the answer is 10, right? Yes, there we go. So this is correct. But then we're trying to do toString somewhere. How about when I'm running through the node, I want the node args to contain the source map, right? Node enable source maps. For sure, Kast run. Kast string to string num int32 as to string. So I have int32, which is undefined, right? For some reason. So what is undefined? To string value, right? The index? Wait, what? Maybe? This thing. Hello, Harry Dree. I want to do 3D, but I don't like using game engines and I don't want to spend a year learning OpenGL. You can try something simpler than OpenGL. I think you should not learn OpenGL. Like you don't want a game engine. You want something that just allows you to draw things, right? Unless you consider that an engine. Like is Raylib a game engine? It allows you to draw 2D very easily, right? I mean, isn't Raylib also like helping you to do some 3D? Raylib 3D. Or do you do a lot of manual work if you do 3D in Raylib? I have no idea. 3D camera free. I mean, there is 3D, right? Maybe what if you just do Raylib 3D? Or are there are like other like things? When I was using JavaScript, I was using the 3JS. I don't know if this is still popular, or maybe there is something that is better than this. I did have like some performance issues with it, but you know, this is used in a lot of places. Macro Quad 3D. Macro Quad is a 2D one though. It's not a 3D thing. Macro Quad is like made for 2D for sure. Hello, Buffer. Using libraries won't help you learn the 3D the right way. Yes, but learning OpenGL is learning a lot more than just learning 3D. It's like learning programming. If you want to learn programming, you don't need to learn C. You know, you don't need to understand how computers work to be able to program. So in a similar way, you don't need to do OpenGL or Vulkan to do 3D. I mean, but OpenGL is a lot easier than Vulkan, but still. All right, so X to string where X is undefined. X is undefined because somewhere. Why is it pointing to this line though, index? Because I'm trying to do to string index. You're allergic to GUIs? GUIs are nice for 3D. I wrote a terminal 3D rasterizer. Do I know 3D now? Yeah, I guess I would say so. 3D rasterizer, I mean like you did a software renderer basically for 3D, right? So you implement your own graphics API instead of OpenGL. That's a cool thing to do, yeah. Let's try doing a breakpoint, maybe. But if I do a breakpoint, then it just runs part 1. I mean, I can just write in the beginning here that part 2 is true. Part 1 is false. Let's try again. So I'm not getting there. Oh wait, I removed my thing. I didn't even get here. Hold on. Wait, there's no way, because this is the reading. Is my breakpoint? No, the breakpoint is working. Oh, this breakpoint is hollow. Index plus equal 1. So, yeah, I guess my source map node is actually correct. Yeah, because plus equal 1 is like... So, yeah, because this is a macro, which expands to index is equal to index plus 1, basically. This breakpoint, I can set it in the macro definition itself, not here. And to figure out how to, like, make that work. So we get here, right? So I'm trying to print index here. So the question is, do I even have index? Can I like do this? Yeah. Lock loop body. Unwind token line. Yeah, because this is unwindable under the hood, so we have line. Wait, where's index? Oh wait, index is defined on the outside over here. Yeah. So it's somewhere over here. Yeah, index is 1, right? So it's not the index, I think. But if I try to go to the next line, I'm not getting here, right? Because I'm pretty sure that this is the thing. Unless it's machine answer. Hold on. Okay. Let's try this. dbg print index machine answer. This will... Yes, machine answer is undefined, not index. Okay. So why is machine answer not defined? Because that is weird, right? Especially since we said that answer is 10. So I should have returned the answer, which is 10 from... Oh wait, solve part 2, by the way, not part 1. So this is what we return. Root machine answer to string. Yeah. Oh no, this has with return, and then this has the returning the end. I'm wondering if it's because this is unwindable and I'm not returning in the end. Maybe it's because I'm actually not transpiling correctly. Let me take a look at transpiler. We have unwindable. So if we actually use the unwind, then it is fine, probably. But if we don't, then so body of the try. This is a scope. Inside of a scope, we have the body, which is try. Yes, that's right. We transpile expression statements body, but this should not be it, right? Yes, this is not correct. We should return transpile expression as an expression, and we should return it. Yeah, that makes sense why it was undefined. Transpile expression body. Okay. Okay, there we go. The answer is 33 for advent of code. Here, 33, and then we can solve for the actual input. Okay, so it is pretty slow still. It seems it's not instant, but it's doing these things. I'm wondering how long this is going to run, because this is how much brute force iterations we need to do, and it was not doing it instant even on the 6000 here. So maybe now we just go into optimizing. This is but it's working, right? If it's working on the example, it will surely work on the actual thing, right? Optimize generated JavaScript. I mean, we can also try the this thing on at least the examples of the last 2 days of the advent of code, if they are still working or not. Let's try cast run day 11. Day 11 part 2. Part 2 does not work. Okay. The vertex is not found. Vertex not found. Let's try running this without JavaScript. Is my interpreter that slow? 5. Okay, no, it's not that slow. 5. It just takes a couple seconds to run that. Someone should make a VS Code plugin where Mario tries to jump from bottom to top on your VS Code and your score is how far he gets, or Camel would win. Maybe it's just my OCaml code that's bad and everybody else who's writing OCaml is writing good code. Without 1000 levels of indentation. Nobody's writing good code ever. You just haven't, if you haven't seen good code, it doesn't mean that good code doesn't exist, right? Except for that man who was mythical for a whole month. Who? Me? I don't remember saying that I'm writing good code. Or you're talking about someone. Oh, the mythical man is like the meme. I see. The only good code is deleted code. You write a lot of comments to explain your code. You want to write a comment explaining the staircase? I mean, all of this is just generating the JavaScript code. I guess I could I'll have like the JavaScript code in a comment here, right? Like we say like if you know, if catched unwind token is equal to the token var, you know. I guess that's what this is generating here. This 30 lines of code is just generating this thing. We can't redeem comments anymore. He doesn't want us littering Kast standard library. Well, I mean, this code is actually going to be deleted, right? The OCaml code is going to be deleted. once we self-host. My VS Code is hanging because I clicked on the generated JavaScript. Okay, it unhanged. Vertex is not found. Okay, vertex is not found. Why? The interpreter worked, which means that it should actually work. Day 11. Let's open that. So day 11 was what? We have a graph here. True, false, false, true. Yes, yes, yes. Part 1 solve. So we have a graph, I guess. Graph. A graph itself is just a map from a vertex ID into the vertex. And we say vertex is not found. How would I debug this? There is more, right? This is the thing, right? Get or init. Wait, what? Get or init? Wait, what? Why is that part of the same state trace? Oh, wait, hold on. So get mode is calling get or init. Get or init vertex. ID. Init. I mean, am I not just trying to initialize it, right? This is collection. So we are calling this function. We're just calling map get or init. Map get or init is creating if there is no key here. So it's calling the init. So init is actually being called. I guess it's what's happening, right? Yeah, I think so. This over here, we are creating the singleton to create the new vertex, basically, which turns into calling this function. And then init is a function, right? So init is a function. Oh, wait, right. Init is a function which is panicking. That's right. Okay, that makes sense. Because get mode is get or init, which panics if it's not initialized. That makes sense. Okay, but who is calling that function? I feel like this stack trace is not complete. Pum, 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 pum. So this is used in over here. So this is part 1, right? Yeah. Okay, we are trying to... Okay. So what is happening here is that I'm trying to get the vertex named U in the graph G. Okay, and it cannot find it. But the way... So we are using graph. This has a map. This is the ID of the vertex in a graph, because vertex ID is just a string. Right? So which means that the map with string keys doesn't work. Let's create a simpler test for this. Right? Use prelude, use std collections map. All right, so I just say that map is map init. It's called create. This should be a new type, by the way. So into say map add map hello world. Map get map hello dbg print okay, some occupied, sure, because that's a reference. Unless we also want to do option. Maybe we should do option as the ref. Let's do option as the ref real quick. We have as a ref, but we should have as the ref, you know? So if I have an option of a reference like this, then we'll get option T, right? Like that. Okay. Some world. And now we want to run this through JavaScript. It does work. It does work. But maybe it works because this is an because there's only like a single one here. Let's try to add hello 2 and let's try to add hello 3. Maybe like something is not correct, I don't know. seems correct. So there is some other issue then. Can I print all of the vertices in the graph? I can print a graph. There you go. If verbose, print G. But verbose is just this, right? Let's say verbose is true. Wait, what didn't work is part 2, by the way, not part 1. So the graph is actually correct. We have something else in part 2. Part 2. Part 2. Oh, because SVR. Maybe SVR is not there? Because that's the only place where I'm calling this function, right? Oh, wait, but wait, this is correct. Because day 11 is the stupid day where they had 2 examples. I need to say that. Because for the part 2 they had a separate example, so this is actually correct behavior. I think my part day 11 is working correctly. I need to say example.part2.txt because it doesn't do this automatically. There we go. So there is no bug. Okay. This thing is still running. It's halfway through on the day 10. Yeah, day 10 is like the slowest one. Okay, let's check other days. Day 12. Day 12 only has the single part. No JavaScript branch at stdsys exit. Oh, because I expected -1 but got 1. Wait, why did I expect -1? There is no way we expect -1 in the inventive code, right? All of the answers are positive always. My puzzle answer is 495. Oh, wait. In day 12 is also a special day where we should take a look at the test, right? So for day 12, we only do part 1 and only on the actual input. I should just do basically cast. I just run the test on day 12 like this. Wait, what? Okay, there you go. Answer 495. So that is correct. Why do I need a double dash here, though? I didn't, or did I always need it? Because I don't think I have parsed this, right? It doesn't exist. Which is weird. But this doesn't see that stuff. I think my interpreter is not having the argv parsed properly. Maybe let's just do this. Let's just do echo dbg print std dbg print std sys argc cast. So this has 0. Wait, unexpected end of file. Why? What is unexpected? Oh, it's because this is a REPL. Kast run. 1, 2, 3. Kast run. Wait, am I doing the dash? Oh, yeah. So the rest of the arguments, if it starts with a dash, then it's the remaining arguments of the thing. Yeah. It's because this is the arguments of the compiler. Yeah, that makes sense. Because I don't know when the actual run arguments start. Okay. Interpreter CLI. Because like argv is just the rest after the compiler, but after the compiler I'm only allowing well, no, if we have the path, then after everything after the path is like the remaining arguments. Actually, hold on. Hello, borrow checker. How are you doing? I have an achievement. The entire advent of code is running through JavaScript, but there are performance problems. So I'm going to try to generate some better JavaScript in a second. After I realize, let's just do this test here. You know, for I in 0 to std says argv rxc dbg print this is argv at I. Kast examples test. Right? It doesn't print anything. That's right. It does not print anything. It's because I forgot to set my actual thing as the first argument. Yes. When I was refactoring the interpreters like CLI here. Let's take a look at the history here. Can I have the history to look better? I don't know. Open on GitHub. Maybe this one, Kast run target JavaScript, probably. Yeah, over here we had path and the rest as argv, and that was what was it. But now I'm just doing the rest as argv, which is not correct. We have argv here, argv. So yeah, argv is just the rest, but that is not right, because the first thing should be the compiler thing that we run, right? So the file argv is filed to argv, file to rest, where file is match compiler path. I mean, it is just compiler path actually, right? Compiler path to string, I guess. There we go. So this is my first argument, and then if I have the second argument, then we do that, right? Okay. So now I can actually run. So this is how you're supposed to test day 12. There we go. Nice. Let's commit this. This should be removed. Everything else is fine. Comment that. I'm also going to update Kast there, I guess. After I commit this thing here. So we do option as the ref. Let's do this separately. Option as the ref. This is just fixing the argv. Fix cast argv. Well, I mean, actually argv is like weird, right? That is not the correct fix for the argv, because it's not going to be right if we run through JavaScript now, right? So if I say cast example txt123, this is what it's printing, right? But if I say cast example 123 target JavaScript, then it's printing three things, right? Compiled MJS, test, and 123. Yes, but it should be just compiled MJS. We should lose the ability to see the original source file here, right? So this is only true for the interpreter. So compiler, yeah. So this is just going to be REST. Let's call this argv accept program, basically. So yeah, when I evaluate, this is the interpreter. So I say that this is going to be argv accept program, and then we add the program, which is like path query to string path, and then we do that. And over here, when we are the node arguments, when we're running, this has argv accept program now. When we're doing the REPL, Then this is the same. Setup argv args. Setup interpreter argv args. Where is the syntax error? I don't see it. Am I stupid?
Hello Shadow_Crushers.
Hello, Shadow Crushers. Where is the syntax error? There is no syntax error. Oh, the semicolon. Stupid OCaml. Bum, 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 bum. I mean, not OCaml. I guess it's me who's stupid who doesn't see the syntax errors all the time in OCaml. But for some reason, it's only happening in OCaml. String list. Okay, is that it? So now when I run through Node.js, we see the JavaScript file and the argument. And when we run without the JavaScript, it also is going to be done correctly. Okay, right. Fix argv. This is just more missing. Add missing ops to JavaScript. That's just a test, it doesn't matter. Dun, 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 dun. Map types, new types, and this is the actual fix JavaScript module module expressions. All right, there we go. All right, so now we want to, I want to improve format time. You want to try to do that? Also try OCaml format profile, please. What do you mean also, though? FMT time. We already tried it, but yeah, we can like just apply the formatting to the entire workspace now, I guess. OCaml format profile. They have their own profile with the name of the formatter. What? What do you mean they have? Who has? Who has what? OCaml format profile? You want this? No profile file. I don't know what you're trying to make me do. Profile is Jane Street. OCaml format offers the OCaml format is a profile. I see what you mean. Okay, so we can do the default. The default we don't like, I guess, so but we can try so like profile is just the predefined configurations, I guess, right? So this is the only configurations that I did so far that I didn't like in the default formatter, but then I didn't think more about it. We can try that. Do an FMT. Okay, we changed 100 files here. Let's see what changed. So it seems like the it doesn't have any like spaces when defining the objects. I don't really. I think I liked the previous. It has like the space after the equal sign, but not before. Because it's more similar to the colon mark, I guess. I don't know if I like that or not. What are the other examples? I mean, that's like the only changes that I see here so far. The leading comma here in the thing, this is similar to the Jane Street. What was changed in this place? A space before the closing bracket. I'm okay with that. I don't really care. Nothing really like important. The staircase is in the transpiler. I guess let's just look at the file. I mean, over here we had the staircase, and then we now have that. This is what it looks like. I think the main difference between this and the Jane Street, maybe, I don't know. Actually, no. Never mind. Well, I mean, this is a little less indentation. I guess like the default formatter is formatting like this basically, which introduces another level of like indentation or something. And over here, instead of indent, like I mean it is the same, but just more lines, because we start the object on the same line as the opening bracket, I guess. Right? Let's try the Jane Street again. Well, I mean, I would assume Jane Street should be the best thing, because Jane Street is the only company who's using OCaml, actually, right? Do I even see any difference here? I don't even see the difference. We can try to actually commit this. Like, it should still run, right? I mean, that's just the formatter. Everything should still compile. Yeah. Let's commit, and I can undo the commit if I need. Use Jane Street OCaml format profile. And then I can change it back to see what's different to OCaml format. Let's see the 100 lines. All right, so OCaml format is trying to format the statements on the same line if they are short. I'm not sure if I like that. I like every statement be on its own line. The double semicolon that Jane Street is doing though. I'm not sure if I like that, but I don't know, it's okay, maybe. I probably can get used to that. So the space before like the colon and the equal sign in the structures is absent in the OCaml format profile. But on the other hand, it introduces the space before the semicolon. That makes no sense. Compact and sparse profiles. I do use like sparse for the type declarations, not everywhere though. Maybe I could use the sparse everywhere. No, I don't. No, I think it's fine. I think Jane Street is fine. You know, I think we use Jane Street. Let's just use Jane Street. All right, so let's get to optimizing JavaScript. So once again, the biggest thing that I'm doing is cast compile. Must compile that, sure. Browser format with prettier. I guess I do want to say output is target compiled JS. Okay, so if we look at the generated code, the biggest issue is that we have everywhere set, get, set, and then we just create the object with get and set, and then we just get, and then we immediately call the getter. Right, which is useless, and I mean it is useful sometimes, but maybe it's not optimized, so let's optimize it immediately. Basically, when I'm transpiling a place expression right now, I said I'm transpiling the place expression, and to reload OCaml language server. Thank you. So this just gives me the expression. So like place expression is basically the reference, right? Which is why we're creating the object with get and set. But instead of returning this, let's say transpiled place, where I will say something like transpiled place is basically, we'll have the getter and setter here in the OCaml, and then we will convert it to the actual JavaScript object only if we create an actual reference in the code, basically. Yeah, so get is a function which returns the JavaScript IST expression, which is the expression which, when evaluated, gives me the value stored in the place, right? And set is similarly the function that takes a value as an expression and returns the expression which assigns this value into this place. That's the idea. So for example, claiming. Now claim is, I'm going to claim the transpiled expression, right? And so this place transpiled place. So we are just, so in order to claim, we are just going to place get here. That's all. That's all that we're going to do. And then when we're reading the place, this is also transpiled place. we're also just going to say place get for now. Oh yeah, this should be a function. Unit. I mean, it's not necessarily a function. Yeah, whatever. Yeah, sure, let's make it a function. It doesn't matter. Yeah, so over here, value is read place place. Place in this is the expression does match. So yeah, over here, this is going to be transpiled place. Does match. So if I have a reference, reference pattern, we are reading the place. Hold on, the place was previously the expression, the place expression, right? Transpiles place expression in JavaScript AST. If I am trying to pattern match using a reference, then this a reading place gives me the JavaScript AST of a thing that is stored there. Of the value there. So read place was giving me a value. So this must be yeah, this place must contain a reference is what this means, right? Yes. Yeah, that makes sense. Yeah. So we need to have like transpiled place, which if I already transpiled it before, right? So like place from JavaScript representation, I guess. So we have the JavaScript AST expression, which is evaluated to a place, which has the get and set methods, basically, right? So this should return transpiled place, which means that we have a get, which is an expression that is calling the get method on this expression, right? Yeah, so we have unit in function into shape is so we're just going to call function is field of object is this is a place in JavaScript. Object is place and field is get. And args are empty list. This function returns that. We're calling this synchronously. Okay. And then set is a function value into, so we're also going to call basically we are going to call, but we're going to call this set with the arguments being the value, right? It's the only arguments that we have. So that's how we do from JavaScript. Place from JavaScript. And then we also need to say place to JavaScript, which has a place which is this, and this returns JavaScript AST expression. So this is the other way. So this is going to create the object with two fields, with field get, which is a function. Arguments is no arguments. Name is get. We probably have this. I removed it. I can probably get it back. No? Where am I creating the things with get and set? Maybe it's raw. Get. Where is it? It's being created where, okay, let's see. Transpile place expression. This is the thing, right? Oh, it was like place of. Place of is the thing. There we go. It's place. Get and shape. Yeah, there we go. That's what we were doing. So place of, that's the one. I'm going to get rid of it completely. But I'm going to have this code over here. So a function, this is the getter. Getter. Getter is this function. And setter is this function. So return. Return over here, place get. right? Yeah. And over here, assign. Yeah, over here I don't do even assign the body of the setter is just so this is going to move somewhere else. The body of the setter is just set. So set must be not even an expression, it's a statement, and it's potentially a list of statements, I guess. So body is just place set, and now we have the variable, right? As the argument, variable var span is none. Okay. Place from JS now is right, this returns a statement list, which is going to be a single statement, which is expression. Like this, right? Okay. Place of, I think place of might still be a useful thing. Right? So place of expression. So if I have the JavaScript expression, then this can return the transpiled place. Now this is just going to be a get is a function that just returns the expression, right? Yeah. And set is a function value into a single assignment. Assignee is expression and value is value. Like this. All right, so when I create a function, I'm pattern matching place of variable argname. Expression has type transpiled expression, but we expected the JavaScript history. But because pattern match now expects not the expression, but the transpiled place. Read place though returns the value, and this must be like place from JS, right? Because this is a Java. So when I'm reading this is a JavaScript value, which is a place itself now. Okay, right. Next, field place. Field place should return transpiled place, which is a place of a field. Yeah, that makes sense. Where object is a read place, which means that this place is also a transpiled place. Okay. Read place. So what is this? Expressions type expression. No, it doesn't. Oh wait, it does. Yeah, it's pattern match. Wait, didn't I just change this? Oh, I said it in does match. Pattern match is like a copy pasta of this. So place from JS, read place. Sure. So let value claim place. So what is this? I'm matching a binding. So if I'm matching a binding by reference, then I'm creating a reference and I have a place, which means that I'm just going to say place to JS. Now place. Because we're creating a reference now. Here, yeah. When I'm assigning field place must also be transpiled place. Field assign shape. If I'm assigning to a place, assign a place is this. And over here, yeah, I'm calling the set method here, but I don't call the set method here, right? Because we have a place, and then I just say assign a place set to the value, and value is just claim place, and this already returns the list like that. That's all that I need to do. Okay. Transpile place. If I have a blocked, then it should be place of transpile blocked. Transpile place. Transpile place should also return the transpiled place. That makes sense. But now place of is this. So I have captured places here. So captured places should not be a name anymore, because I don't necessarily store it in a name. I just have a transpiled place here, which means that transpiled place should be defined first. So we don't have place names. I don't have place names anymore. Instead of say captured places is... So we have a place value, right? Yeah. So I should say... place is a place of this value. Yes, that's all that we need to do here. So this is the transpiled place, and then that's literally what we store here. We prepend place name is place, and we don't. We transpile the value and we assign this to the value, and we return the place. And I don't have the var even. I just do this. These captured places. This is already has the place basically for me available. Okay, nice. Transpile place expression. If I have the field, then... So when I'm getting a field, I'm saying that I'm assigning the object that I'm getting the field of to the variable, and then I'm returning from inside of a scope, which is an anonymous lambda being called immediately. I'm returning the... actually field here, right? But if I have the field expression here already, right? Like, yeah, I already have it here. So we transpile place expression object. So this is my object, right? And then we say field place where object is this, and then member is this, and this is just giving me the thing, so I don't even need to do anything else. Okay, if I deref an expression, if I deref an expression, so this expression evaluates to a reference. This expression evaluates to a reference. So we transpile expression. This gives me the JavaScript thing, and then we say from place from JS this. Okay. Temp. A temporary variable. We just assign it to a temporary variable, and then wait, hold on. If I have a temporary variable, is there even any like use to mutating it, you know? Like, do I even assign it to a temporary variable? Because if I not just need to get the value, then I just get the value. If I... No, I probably should, yeah. So I assign, so I evaluate the expression, I set it to the variable, and then I return the place of this variable, and place to JS. Expression has type is JS AST expression. I feel like, no, hold on. If I have a temporary expression, hold on, no. Can I make this better? But this is basically the... I just need to do now place from JS here. Let's keep it like that for now. When I'm trying to assign... then I first assign the value to the temporary variable here, and then I assign to the place of this variable. But do I need to do that? Because this is a place expression. Why don't I just assign to the transpiled place expression value? And I get rid of this temporary variable. Maybe a good idea. Transpile expression. If I have a reference that we transpile place expression, this gives me the place, and then we say place to JS, so we convert it to a value with a reference place. Sure. If I have a pattern matching, I first evaluate the value anyway. Wait, do I? I mean, yeah. Transpile plus expression. Yeah, so I need to like store this as a reference then. When doing the plan. Okay, that's probably good. Okay, for now. Place 2JS. So then I pattern match. Matched. This must be a transpiled place, right? Which so this is just actually now place from JS. Like that, right? Okay, is that all? Hold on, that is, it says success. Does it work? Day 10, by the way, finished running. That's nice. Can exit that now. Let's run day 12. Okay, it's not working anymore. Unexpected reserved word. Where? That's the question. Unexpected reserved word. What word would be reserved? Let's run examples. Hello world. Unexpected reserved word. Okay, makes sense. Has nothing to do with what I'm transpiling. Unexpected reserved word where? Okay, wait, well, it was formatted here. Oh, return, wait, hold on, return await is not doing it. Oh, wait, I see. Hold on. Return await. Because we have a getter, so we have a function which returns a reference, right? So in order to call this function, we need to be in like the async context. Does it mean that my getters and setters should also be async? I can do that. Jane Street made my pipes look better. Yeah, I see. That's what this parse means, this parse setting. It places every item on its own line. So I only had that enabled for the type definitions before. But they enable it for the pipes too, sure. Yeah. Let's let me think about it here. So I have an expression. So the value. No, hold on. I need to like understand what this is. So over here I'm doing the pattern matching of something. I have left and right. This is looking like the trip join. So I'm basically matching left and right here. Right? So yeah, left and right. There we go. We are creating a tuple with left and right. But why is this async? Wait, because it is a scope, and scopes are always async there. Yes, even though there is really no async stuff inside of here. I think I for now will. Hello, if it's Lee. I think for now I'm just going to get my getters and setters async. True. Okay, so hello world works, right? Hello world works, day 12 of the advent of code. Expected. Okay, yes, day 12. Let's say day 8, for example. Okay, day 8 did not work. It said pattern match is not exhaustive now. May I ask a question? Go for it. Sure, you can ask anything. But will I answer? That depends on the question. Pattern match is not exhaustive over here. Is there an easy way for you to learn VS Code? You have about a year to spare. What's there to learn? Just open it and start using it. What do you need to learn? Just use it. It's not Vim, you don't need to learn it really, right? Unless there's something confusing in the UI to you. There is only one thing to remember, which is the command palette. If you want to do something, you officially know absolutely nothing. Well, what are you trying to do? Why are you trying to learn VS Code? You have a project related to Linux. Why do you need VS Code? Do you like, what did you use to make a project? You can forget and learn VS Code 365 times over in 1 year. Well, I mean, no, there are things to know about VS Code, but you can use it without any knowledge. That's the basically the point of VS Code. It's usable by just opening it and like when you open the VS Code, it literally opens by default this thing, right, which says show all commands, like just to read what's on your screen, you know. I guess that's not very easy always. You can also, like, if you use VS Code these days, you also have the chat GPT or something, right? Opened here. So you can try that. It's not set up for me though, right? Yeah. I don't even have it set up. But you can set that up and ask AI how to use VS Code, I guess. Like, just figure out what you want to do, and then just figure out how to do that. How to write text? Well, you just start typing on your keyboard, right? Just like you do it in the Twitch chat window. You want to write shell scripts? You have my own distro, an Arch-based project. And I also want to develop my own language. Made a 5-year-old plan for myself. Spend 1 year learning VS Code and C, so that's my plan. Wait, what? You have created your own distro based on Arch, and you don't know how to write text in a text editor? I mean, what did you what did you use to create your own distro? Unless distrom is not distro. What is distrom? How did you create your own distro then? Like, don't you need to open a text editor and write some text to do that? Or did you like vibe code it or something? This pattern match not exhaustive, and when I'm splitting, but that makes no sense. Vibe code. I don't know. If you like vibe code, I suggest vibe learning VS Code, I guess. Pattern match non-exhaustive. You realized you have interest in actual coding and not vibe coding? Alright. Well, you use VS Code just like you use your chat window when you're vibe coding. You just open VS Code and then you just put the text here. And then you can save it to a file. Have you ever saved a file on your computer? It's like... I don't know why you need to learn VS Code. It makes no sense to me. Maybe we just take it as granted these days, but there's actually something to learn. Hello, Giancarlo, who's learning VS Code. Obviously, they're trying to make their own programming language, but they don't know VS Code yet. So they're giving themselves a year to learn VS Code and C, and then they're going to start making their own programming language, is what I understand so far. You've done some things in VS Code but never looked into it much depth. Okay, well, I mean, I guess so. Like, the way you learn usually is you figure out what, like, in my opinion, the best way to learn is to learn by doing. So the question is, what are you trying to do, right? You don't just learn thing for the sake of learning a thing. You just try using it for a thing. If it is too difficult, you can try to like instead of doing a thing, because like you don't understand how to even start, it means that you need to split your thing into multiple smaller things and do a smaller thing first, right? So just first figure out what are you trying to do, and then figure out how to do that in VS Code or in C or like wherever. Okay, how do I debug this? In the age of endless complexity and 100 layers of abstraction, the best way to learn is indeed to start with C and write very crude and simple things. Well, I mean, in my opinion, C is the wrong way to start, but sure. Like, yes, there are 100 layers of abstraction, but do you need to know the details of how the thing is abstracted? No. Which is why I think the best way to learn is actually JavaScript and not C. But, yeah. If I was dead, I would be turning inside of my grave because you don't like JavaScript that much. I guess. I'm not saying that JavaScript is good programming language, but it's a good programming language to start learning programming when you know nothing. Because it doesn't overwhelm you with unnecessary low-level details like C does. Unless you are trying to do low-level stuff for some reason, but like, I mean, I guess it depends what you're trying to make when programming. Yeah, Python and JavaScript are like good for learning because they allow you to basically write anything, even if it's not correct, and run it immediately, right? So being able to make mistakes like that, and then like figure out why it's wrong is how you learn how programming works. If you instead start with Rust and you see the borrow checker error, then you're going to just hate programming immediately and you're going to rage quit. I would assume how it would work for most people. That's actually like I believe when I was like learning, well, I wasn't really learning, but when I was in in school and my classmates were learning programming, right? They hated it, and I think they would hate it a lot less if they were not taught C++ as their first language. A shell language that isn't Turing complete is there just to run stuff. All right, let's see here. I have a bug that I introduced when I was trying to optimize my JavaScript. Now we need to figure out where it is. I'm saying that pattern match is not exhaustive. Is it this pattern match that is not exhaustive though? I need to wait. Hold on. I need to actually disable the thing now. Kast transpiler. Kast transpiler. No, Kast interpreter CLI. Like the argument, which is source maps. Enable source maps. It should not be enabled if I am using the formatter because the source map is not correct anyway. Maybe I actually want to remove this. Or maybe I want to have this as my argument myself. Node args. Or I guess like here's my arguments. Maybe I should have enable source maps here. Boolean. Is that what I want? Okay. So pattern match is not exhaustive over here. This pattern match. Okay. What is this pattern match? What is this pattern match? So yeah, it's a pattern match with 1, 2, 3 match branches. Wait, I can just generate this. I'm just stupid. In the over here, pattern match not exhaustive. This thing I can just like make string pattern match is not exhaustive at span print expression data span, right? And then we're going to see this thing. Pattern match is not exhaustive over here. This one. This pattern match. Match node. Yeah, left subtree, right subtree. Okay. If it's not exhaustive, how about we debug print the matched value? Can I? Can I say console log matched get. Oh, but this is the thing. My god. I cannot do that. Well, I mean, I can do a call. I can do a call where function is console log and args is the single argument is the matched get, like that. Well, always shape is expression, shape is call, span is none, like that. No? Oh, and yeah, and async is false. Okay. Wait, hold on. The tag is a right subtree. Hold on a second. I have the right subtree. So matched is a thing which has the right subtree. Which is correct, and this should match this pattern, right? Yeah. Okay. Let's get rid of it. Sure, I can keep this in the logs. Maybe. Wait, what? Oh, because this should be a string, not raw. Right? So yeah, unmatched value is this. Sure. So let's take a look at does match. Does match basically doesn't work, right? So I'm matching with a variant. Good night, Nigel. I'm trying to pattern match with a variant. So we have a var variant. I'm assigning. I'm reading the place here. So then I say that if the tag is equal to the this symbol, it should work. Let's take a look at this code, right? Okay, so this value is the one which has the tag so over here this has the tag node, and this is the tag left subtree. Well, I mean, it was literally the right subtree, right? So this over here, right subtree, right subtree. There's only one right subtree supposedly here. It should be. So the variant itself is the matched get, right? Which is the one that we were printing here, which was unmatched. So I know that this over here is the one which has the tag equal to this. So this should have true. So, but it was not true. Why not? Maybe let's log the tags that we get. Let's do that. Shape is call, async is false, function is raw console log. Args is something. And this is expression. I'm going to log here the this and that. So the tag of the object and the tag that I'm checking against, right? Oh, wait a second. It says over here symbol node, symbol node. I see why the language is called the camel. Why? Hold on, let's also just do the variable itself here. Log this thing. The code looks like camel humps. I can write code like that in any language. Wait, what is that? What am I seeing? Why is this symbol node here? Am I not having the symbol right subtree and data is undefined? Or maybe like, hold on, is it because... Let me take a look at this pattern match. Yeah, I'm trying to pattern match the right subtree. I don't understand. Hold on. So I have an unmatched value, which means that the previous thing that I should have seen in the log before the unmatched value is the variant, which is this, which is the same value as I'm logging here, right? So unmatched value is symbol right subtree, and this is and data undefined, but the previous log is printing my value as one with the symbol node. Why is that? Because get, okay, hold on, maybe it's because when I'm getting, right? What does get mean? Get mean that we are actually well, I'm calling function f here, right? Wait, so I actually wait, hold on a second. I'm actually doing this multiple times here. This is supposed to be a reference, so I'm not evaluating it. First of all, that's a bug. So what should I do here? This is in pattern match. expression match. Right, so I'm assigning this to place to JS transpile place expression value. So transpile place expression is not correct here. What am I trying to transpile here? I'm trying to call function f with reference to node, right? Which means that it's a new temporary expression. So I should see a temp there. But the temp is over here inside of it, which is called every time I do get. And that is wrong. So I guess the problem is place from JS. Place from JS. We have an expression which is equal. Which is when evaluated gives us the thing. I cannot think about my code and listen to this. I'm sorry. Should I try to shut up? Do you hear my keyboard? I like how on some streams you can just hear the keyboard noises. I can put my microphone towards it though, maybe. What about now? What if I get rid of the noise suppression? How much noise is there though? What if I fart on accident? Your guys going to hear it now? It's like we're co-working. Does it sound nice? Should I get rid of the noise suppression? Hello? 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 Yeah, you can hear it like that. Well, I mean, yeah, so now I also make my microphone face towards me, so it should not be like we're on a phone. Right? Now we hear both. All right. It was better than compression with compression. So professional. We have two opposite opinions here. I don't know. When I come to other people's streams, I like hearing the keyboard sounds, but it means that there's also other noises too, right? Okay, basically when I say place from JS, it means that I need to evaluate this to a value first. Transpile place. Wait, but I cannot. Transpile place only allows me to have the get and set. Maybe like I need to change this type to be something else. Or maybe transpile place should be one of the two things, you know? Either I know how to get it directly in OCaml, or it's a JavaScript one. Do I have 7TV installed? No. Let's just say OCaml or JavaScript. How about that? So the transpile place is one of these two things. So place2.js is going to like match place with OCaml place, then we do that. But if it's already in JavaScript place, then we just return the JavaScript one. And then place from JavaScript is basically going to be a JS place. And that's all that I do. Loose and strict comparison operators are very cool features for JS. I thought that the loose one is the mistake, no? What's the difference even? I don't remember. Loose versus strict comparison. Loose equality is symmetric. The strict equality operator does not attempt type conversion. I mean, yeah. Yeah, like, you always use this one, basically. You never use this. Kind of, right? Sameness. Well, I mean, sometimes, for example, you have a number, right? I'm not using like begins yet, but basically you have a 0, and then you have a 0b, n, 0n. This is the big number. So 0 is equal to 0n, but it's not triple equal to 0n, right? Because this one is a big int, and this one is a small, like, is just a number. So I guess like it maybe you could use it like there. In C you would parse it to int. I mean, yeah, I feel like in C though you would automatically like convert the type, which is like an int64 to an int32 automatically when comparing the ints of different sizes. So that would be like the same here. But for I feel like for strings it must be explicit, because otherwise it I don't know, like why would you want it to parse it to int automatically, basically? Or hold on, in JavaScript it's not parsing it to int, it's converting the int to the string, right? Before doing the comparison, I think. Place of expression. So this one is OCaml. So place get. Yeah. Match place with. Now, if it's a camel place, then we just do place get, and if it is JavaScript place, then we do root place, by the way, is just implemented using claim for now. So this is where we call args empty, async is true, function is a field, object is place, field is get, place, assign to place, assignee place, claim place, assign to place, transpiled place, expression, place value, place with camel place set value, JavaScript place, then assign. This should be a statement list, right? So this is going to be assign no, not assign, call function is field, object is place, field is set, arguments is value, and this is an expression. shape is called. Like that. So matched yet. This should be read place matched. This is not going to fix my bug though. Oh wait, is it? Wait, it actually fixed my bug though. Hold on. Okay. Alright. That's good, I guess. Console log. When pattern matching is going to be removed. When the pattern match is not matched, it's fine. Okay. Nice. Advent of code still works. What was a long day to calculate? I think wasn't day 8 actually the long one? I think day 10 is the longest, right? Yeah, this one is doing BFS. It is still doing BFS. There's no way. This is doing it. I'm running here on the example. Day 10. Day 10 BFS. Yeah, it runs instantly here. Before my changes. But now it's not running instantly. Now it's running infinite amount of time. I'm assuming I'm still generating the too many things. I'm starting BFS. Like where am I actually stuck is the question. Day 10. Starting BFS. Can I like print 1, 2, 3? Here. 1, 2, 3 is printed. Let's print 1, 2, 3 over here. Okay, this looks like this is the infinite loop. So dbg print state. What is the state that I'm... State is 8. But it means that... Okay, can I print the queue itself? What do we have inside of the queue? This is a trip though. So yeah, this is a trip. There's a bunch of things in the thing. Right, value 29, value 8. Yeah, looks like 8 is the first thing. So I'm never popping from the queue. So queue pop doesn't work, right? Let's create a test. Let's say use std collections. Queue, let queue is queue, create queue push. No, we don't do this. We say queue push queue hello. dbg print queue pop twice. Okay, so the second one is doing out of bounds. Because we're not allowed to do that, because this does not return option right now. No, it does do out of bounds. So wait, it probably means that I actually pushed it, right? Back. Or does it not? dbg print before pop is q length q, and you know, after pop, let's print the length before and after the pop. Yeah, no, before and after pop it is 11, which is completely wrong, right? So q pop did not work here. But it works in my example. Let's try pushing multiple times. Let's do 4 in 0 to 10. Okay, that worked. Oh, wait. Okay, this is wrong, right? We see 2 zeros here instead of just seeing 0 and 1, which is what we should see. Okay, Q pop. How do I debug that? It's not been mutated or something, but it was mutated at first, right? When it only had a single thing. Then we print 0 and then we do out of bound. But what if there is only 2 elements? Then it is not doing it anymore. Okay. Right. All right. So wait, now it is 0, 1. Hold on. So it's RNG, right? I mean, it is RNG. Yeah, it is RNG because I'm using a trip under the hood, which is the randomized data structure. So it depends which one is becoming the root of the tree. Makes sense. So it's popping. So split add doesn't work properly at index. Okay, how do I debug now? Um, well, trip split at. Wait, hold on. But I am getting something there, right? This over here, this assignment probably doesn't work, right? This assignment probably doesn't work. Can I say dbg print first rest? So this is when I'm popping. So when I'm popping, the first one is the one with the value 0, and the rest is the one with the value 1, but it still has the... Okay, no. Yes. Let's do q is q dot inner, right? So this is my trip. I have a queue which has this time it worked. I need to, like, when it prints 0 in the end, like this. Yeah. So we have a queue which has value 1 being the root because the priority is higher here, right? And then the left subtree contains the 0. So when I'm trying to split it, it returns the first, which contains the value 0, and the right still contains the 1 and 0, which is not correct. So split at is not correct. Okay. Split at. Split. Can I, like... Can I do this? Let b is this, dbg print b. So I'm splitting the right subtree, which is not correct. Oh wait, no, right subtree is correct. Hold on a second. dbg print v behavior is b, right? That's what I want. I'm printing 0 in the end. So behavior is right subtree, the node is 0. Count is 1. Q. Wait, why is this printed twice? Over here. Oh, wait, it's printed twice. That's the issue. Is that the issue? Like, because this is printed twice, it means that this expression is evaluated twice. Right? Let's do just print. Right? So I printed 0, and then, like, on the second pop... Well, I mean, there are 2 nodes, though, right? Hold on. Match F node. Let's try this. So when I'm splitting node is a reference. Let's say node is node dereferenced, so I can actually see the value there. I'm having 0 in the end. Okay. Okay, so here's my first 0 is popped, supposedly. Let's actually see how the first 0 is being popped, right? So, like, right in the very beginning, I'm trying to split the entire thing at node index 1. This node index is 1 because the left subtree contains the 0, this contains 1. So behavior is that this belongs to the left subtree. Now I'm trying to do the 0. Oh, but wait, hold on. I'm trying to do the 0 at the index 1. I mean, yeah. This means that this node belongs to the left subtree. Yeah, this node belongs to the left subtree, but then it's called twice. Okay, so the problem is that this over here is the function that's called twice. We have mutation here, which like breaks stuff. Makes sense. So this is called twice because when I'm doing the matching here, the matched expression is called twice, right? If I try to say that behavior is f node, and then I match the behavior, there still is a bug. So it's not in the pattern matching, but it is somewhere else. How do I guarantee that I never call? Maybe I should just look at my code better. So place of is the thing, right? Yeah, place of. I mean, yeah, this is the incorrect thing. Yes, place of a JavaScript expression. This should only be called on the expressions that are already calculated. So let's take a look at where this is used. So yeah, it should only be called on the simple ones like variable, argname. That's okay. Place of like field, variable data. That's okay. Place of field. But field over here is a read place, and read place might be yeah. Yeah. place of field data. Don't I just do field place? Hello? Of read field place and field is data. What is the microphone that I'm using? It's DGM20 USB microphone. I don't have the box here anymore. Maono? Yeah, Maono GGM20. Is it good? I don't know. You tell me. You are listening to the stream, right? I have the noise filtering right now. If I disable noise filtering, this is the raw sound that we get. I'll hit us. This is the same, does match. This should not be place off. This should instead be field place. Oh wait, what is the var here? Var. Oh wait, I'm actually reading the place here, right? Yeah. Okay, then I have variable.data. That's kind of okay. First it was my own amic, all was good, then became the beard, no straight thinking after that, shaky concentration, then arrived a camel, then downhill, been downhill ever since. He's not that rude usually, only when this code is not working. I'm always angry at my code. Hello, happy Nora. Maonas are very good for their price. Yeah, that's what I heard. It's a relatively cheap one. Was suggested. Hold on. Like, why is my code not working? Can we make my code working, please? This is still being called twice. Okay, place of field. Okay, field place is place of field, which is a read place. This doesn't work. Does pick up noise and table noise like all mix. Well, the microphones they like different. Mono is the they're like condensators and like dynamic microphones, right? They work a little differently. Something. Place of. Do I just undo my changes because everything was working previously? I'm trying to make my JavaScript better and smaller, but I made it buggier instead. So the problem is when I say place of expression, we create a getter here, which just evaluates the expression, but actually multiple times. Which is why this should be a simple expression. And field place is not a simple expression because read place. Well, I mean, hold on. Reading a place should always be a simple expression, I guess, right? If we have this invariant, because reading a place, this is basically dereferencing a reference, right? Should be easy. Okay, sure. So maybe it's some other. Let's just go further. Wait, hold on. We have this transpile binding. Transpile binding should give me a place always, right? Where the binding lives. Right? This returns transpiled place. Yeah, that's right. So transpile binding should just give me the place already, I think. Transpiled place. So if it's a modular, then this will be place of this. And this is place of variable. Transpile blocked. This returns the expression. Place to JS. Invalid left hand side in assignment. Nice. I broke it even further. Oh no. Oh no. Maybe when I'm transparently blocked, this one, right? Binding. What was here previously? We just say transpile binding, which was an expression which was not doing the value, right? Yeah. No, this is binding get basically. JavaScript. So blocked expression is right now. This is always we only have a binding, right? So maybe like this should return the place, claim ref, field ref, right? Like isn't this a place expression? But I mean, this is a value, supposedly. So this should be binding, which is read, claimed, maybe, I don't know. Sure. Okay, that's better. That's better. I didn't break it, but it still is broken. So once again, place of is wrong. So place of transpile blocked is supposedly not. I need to like make it more typed basically so that we cannot introduce a bug easily, although I don't see a bug right now. This is a var, right? Like, why is it like that? Okay, maybe I'm assuming something that is not correct, right? So the question is, what is actually wrong? So split at, let's say this, we have split at. So split at is called on the same node twice. For some reason. Because this function is called twice. Okay. So I think the question is... maybe this over here, when I'm just like assigning this, you know? How about we do this? We say that this expression, we just say dbg print like this. And then we do dbg print before and after, right? So this is supposed to call this function once. Okay, it is called once actually. Okay. Which means that something else is called twice. Before. Node. Okay, so we call this before on node with value 1. Then we call split at... we call this function here after. Then we do go into the inner node. We go call this on the inner node, right? After. But then I call this again on the inner node. Right, I call this again on the inner node. Why? Only on the inner node. So we return a right subtree. So we're doing this. So I'm calling the function split recursively here on the left subtree. Is this being called twice? Oh, wait, hold on. This is being called twice. I think I know that because we are doing the pattern matching and the structuring of the tuple here, right? So this function returns two values, and then basically like calling this thing twice when assigning to this and then when assigning to this. Is that what's happening? Let's do like a simple test. Right? Let's do this. Let underscore and underscore is this, you know, dbg print haha 1 and 2, you know. something like that. So Kast run examples tests. And now it's not been called at all, right? So I don't. It's not even being evaluated because I didn't assign it to the values, right? Because underscore is not doing anything. There we go. 2 hahas. Okay, I found the bug. Now we need to fix it. So like this right side should always be evaluated. I guess it's because of assignment. Transpiler JavaScript expression assign, right? We just do assigny and then we transpile place expression here. So transpile place expression. I have a place and then I assign. But this transpiled place, hold on. Are the tests saying it works? Yeah, it was. My tests are the advent of code solutions. This is my test. So it was working, then I'm changing my generation of the JavaScript and it stops working. So yeah. So I've introduced the bug. And I'm going to fix it. So transpile place expression is involving some calculation. So why do I return here this? Advent of code-driven development. Yeah. Name. Place from JS. Okay, place from JS does not work. Because this is supposed to be like a simple JavaScript expression here, but it's not simple. Yeah, I should introduce a new type, which is called like simple expression with like no side effect, basically, is what we're looking into here. So when I'm transpiling a place expression, we have the side effect of actually calculating that. We assign it to a variable, then the variable itself. This is the simple one, which means that, so when I transpile the place expression, I potentially need to calculate something and then return the place as a value, right? Yeah. So does it mean that this thing that's returning a place expression, or maybe like even transpiled now? Type expression without side effects is no effect of JavaScript expression. Okay. So get when we do the from camel, this also must be no effect expression. JavaScript also should be no effect expression. Place to JavaScript. This is going to be no effect expression. No effect. Return. Please get. Let a no effect get is place get in get. Place from JS. This is going to give me no effect expression. Place of no effect expression. Assignee is let no effect expression So yeah, so now we can like go over and assert, right? This is a variable, and this obviously has no effect. So we can do no effect easily here. Place of. So we have a field of a variable. This has no effect. And this also has no effect. Okay, so like instead of yeah, yeah. Now we like see this in the source code when if I change this, and yeah. So assign to place. We have transpiled place. If this is JavaScript place, so we just say that let no effect place its place. And then do the other things. When I'm claiming place get, let no effect result is place get in result. JavaScript place let no effect place be placed. So read place is always going to, this is a no effect expression always, right? Claiming a place though is an effectful expression, potentially, because later it's going to perform the copies or move the things out of a place, right? But not yet. So for now we can just say no effect claim. Maybe I should instead implement claim using a reading place. And since this is not effectful, we should not do the async, right? Like, async should not be true here. So claim is just going to be let no effect result be read place in result, right? 10. Maybe let's do async get set somewhere, so that async get set is going to be false. So get async get set, async get set, get async get set. So get is called on the yeah, here's where we define it. This is where we'll use it. And set also should be in 2 places. Async get set, async get set. There you go. Okay. So value read place. This is a no effect one. So if this is a no effect, reading the place, then why do I even assign it to a variable if I could just read it every time? I mean, it doesn't really matter. We have an if here anyway. This is does match, yeah, sure. Let's no effect result be replacing result. For data, this one has no effect. Place to JS place here is a transpiled place. I want to create a reference here. This is pattern matching. Hold on. Binding. Oh yeah. No, right. So value is just creating the reference. Which is just that. Say let no effect value be this in value. Field place, transpiled place, this place of field. So read place is no effect. And we return no effect as a result. So we can see that this has no effect here easily. Transpile place. So transpile blocked. Transpile blocked. Blocked value. Or should I'm claiming a binding. Can I for now say that this is transpiled place and then just return this? I'll think about it later when I implement the other ones, if I need even. Place of. So this is a variable. You know what? I should just say place of variable. Value name. Place of variable arg name. Let place of var name is place of no effect, shape is var name, span is none. Right? Place of var field module var binding name. I want this also. And this place of var binding name. Place of var field. Var field is. Wait, what did I just remove? That I copied it, but I didn't. Yeah, this is just the place of no effect. Shape is field. Object is shape is var name. Field. Like that. Transpile value, this gives me an expression. Transpile blocked gives me a place. So I just claim this place. Transpile place expression. Okay. This over here. This returns transpile place. Transpile place expression, right? We are trying to dereference an expression which evaluates to a reference, right? So this obviously is not an uneffectful expression, because calculating a reference might involve some effects. So how do I do this? I need to return when I'm transpile place expression how do we calculate this thing basically? Right? So like I'm missing like the borrow checker here so that I don't write bugs. And the move semantics. Maybe. Is it really that the transpiler is not piling enough? It's piling too much, actually. I'm trying to unpile the pile. There is too big of a pile currently. Okay, so transpile place is basically, so this is basically like a pure expression, but this over here is impure, which means that transpile place expression might involve some calculation, which means that this should return not just the place, but also the calculation that was happening. Which basically is the statement, which is statement list, like that. JavaScript st statement list. Do they appreciate the mic? Well, we got the comments from Hitus who said that there are better mix. I guess. Also, I like I was trying to remove the noise suppression. Oh, you are going to hear my cheers quick though if I do this. Do you hear this? It's not squeaking as much right now. Hold on. It does sometimes. Heard only once. Alright, yeah, but you can hear the keyboard. So I was saying that I like hearing the keyboard on other people's streams, but someone said that it sounds better without, I mean, with the noise suppression. So, which kind of makes sense. Can I suppress the noise, but not the noise of a keyboard? That's the question, I guess. Maybe I just need to change my noise suppression settings. I just use this thing, noise suppression, RN noise, but there is no settings here. With an AI? Isn't this AI? I think this is AI, but I'm not sure. Maybe there is like a different plugin somewhere. Okay, so when we dereference, we say that we transpile expression, then we assign this expression to a value, right? Can I see this? Place expression. over here, this is what I'm writing, right? When I was dereferencing, we were just transpiling expression because expressions, this was always like the effectful expressions. But now we need to assign it and then like have that stuff, yeah. Let's just say this, let var be gen name ref. We're creating a reference here, right? And then we say that statements is assign or let var value is transpile expression, and then we return statements and place of var. That's all. Don't we established long ago that AI would wear gray t-shirts saying code forces? And keep on pretending doing bugs forever on stream to not get caught. Yes, exactly. So temporary expression is also the one that is evaluating it. Wait a second. I'm transpiling this expression into a reference. So this is not a place of var. This is place from JS. So this is a JavaScript reference, which is this variable, right? Place from JS. var place from JS var name is place from JS, no effect, shape is var name, span is none. Place expression temp, we say, so it's going to be very similar to deref actually here, but we create not a reference, we create a temporary, which is value is now going to be transpile expression. So we have the statements, and now we have not place from, but we say place of var, and that's all. Okay. Transpile place expression. So now transpile place expression has the statements. So we need to do assign returns a list also, right? Place. Let's see here. Let statements and place is transpile place expression value. And then we say statements and assign. We follow the statements with the actual assignment. Okay. Transpile expression. If I have a reference, place, this is a place expression. I transpile place expression. So I have statements list. Okay. So we say place to JS. Why is typing not saved? From this kind of place from JS mistake. Translating to mix, there are mix which offer more functionality, but are more expensive than mix that offer the basics and are way cheaper. Can we agree that you don't necessarily need a studio mic in order to stream? I'm using the exact same mic as Scooby for a bit of a year and never had any problems. This voice is very clear. How clear is my voice right now? 1, 2, 3. Clear, clear. Dirty, dirty. By the way, some people said that my mic is still doing the compile mix sometimes. So maybe the fact that I got the new mic in like instead of my old mic. I don't know. It seems like it happens rare than it was happening with the old one, but it is still happening. Unless Pigorli is trolling me, which might be the thing, of course, because I never checked. So claim is similar to creating a reference. So I just return not a place but the value. Value. I just return claim place. A match, a match, a match, a match, match. That statements matched place is transpile place expression value. Let statements. Why is this even a reference? That makes no sense. I mean, because I'm modifying it, but I can just introduce a new variable. Let statements is statements and let value is place2.js matched place. Place from JavaScript var statements is statements and branches pattern match. Okay. How is that JavaScript translation going? The entirety of the advent of code is working. Was working before my current changes, because I'm trying to optimize the generated JavaScript. Specifically, as you can see, I'm like doing the places a lot right now, right? So basically we have the same semantics. Let me just explain a little bit, right, what I'm doing. We have the semantics, just like in Rust, where we have place expressions, and when we do something simple, like this, you know, let x be like high, like, I don't know, c, and then x, right? Like this. And then we do cast compile, right? This is going to be compiled into so we first like assign to the variable x the temporary constant c, and then we read place. Why is it read place actually and not the claim here? Interesting. So yeah, basically what I'm saying is that when we see just x in the source code, it's not like translated directly into x. It is reading the place, which is x, right? So a place is basically a reference, a pointer, right? And then we're dereferencing that pointer. That is very similar to like C++ and Rust, how they are doing things internally, right? So in JavaScript, the pointers don't exist, but we can create a reference to a variable by having like a getter and setter, which return and assign to the variable. That's how we get a reference. That's how I represent the references in JavaScript, with a getter and setter. So they exist, but they are hidden, and we are unhiding them by creating getter and setter, right? And that really results in a lot of like primitive types are passed by value by arrays, and objects are passed by reference. Yeah, there's also that. But that's a different kind of a reference, though. That's a different kind of a reference, I guess. That's just the representation of a value. But when you have the like basically when I say a reference to a variable, like if a variable itself is an array, because arrays are backed by reference, are basically like implemented as references anyway, right? When I say a reference to an array, I basically mean reference to reference, you know. So we're referencing the variable that contains in itself the value of an array, which is a reference under the hood, you know. It's a little weird, but here's the transpiled JavaScript, I guess, right? Here's what it looks like. That's not what it looks like. Format, right? So there you go. It looks like something like this. So this over here is creating a reference to the temporary variable, right? So it's an object which has a get and set. Also, everything is async. Yeah, we have the source maps too. I can place a breakpoint in my Kast code. I'm working the browser too. Yeah. The source maps are not very like nice right now. They can be improved, but some breakpoints work. Yeah. So yeah, I just create a lot of like these objects, and then I invoke the objects getters immediately, right? So I want to like optimize this because this probably, I'm assuming that this is what leads to my current performance problems. But this is not very easy. So like I started by doing the easy route, where we just always create the object and then call it, and we also create a lot of instantly called functions for the scopes, right? Because in my language everything is an expression, and like in JavaScript not everything is an expression, but in order to turn everything into expression, we sometimes create the closure and invoke it immediately, basically. I can show you. Let me show you again. Because why not? I can so I can compile the so here's the example of the code that that uses the Canvas API that prints some HTML, document body, inner HTML. We append the hello world there, and then we do some 2D context stuff here, right? So I can run this by doing this localhost. There we go. We have the house drawn, and we have a hello world, and over here we have a debugger. Here's my source code where I can put a breakpoint. I said I can put a breakpoint. It's because I formatted it. I need to unformat it. Formatting breaks the source maps. Okay, there we go. So now I can put the breakpoints here. And we can like go to the next breakpoint, and we can see the house drawn and stuff. Yeah. But as you can see over here on this line, I actually have 2 breakpoints. One over here when I'm calling the function, and one over here like because of something. I don't know. Could be improved. I'm not sure if I'm actually going to use the debugger much. So because I'm just used to debugging using printing. Print debugging is the best kind of debugging, is it not? How often do you actually place breakpoints in your code? I literally never do that. Unless I use Java at work. So, because, yeah. Printing is way faster, but when you need to grasp the context of the whole execution, then debugger is way better. You can introspect all stack levels. Yeah, I understand in theory, but in practice, it like whenever I try to debug, I just end up wasting a lot of time. Whenever I was trying to do that. So I was doing a lot of competitive programming back in the days, right? And like wasting your time when doing competitive programming is basically means that you're wasting time, right? So it was like is what show it was actually shown by countless like hours of trying both ways that print debugging is a lot faster to find the bug. But maybe that's like a specific kind of programs, so who knows? Maybe for some programs it is better to debug. Well, I mean, yeah, like I said, I do use it at work. Thanks for the prime by Jar. So it does depend on like the kind of an app you are writing. And how easy to like place a breakpoint and like make sure that it's triggered in the correct circumstances, because sometimes the breakpoint is going to be triggered where you don't want it to be triggered and stuff. Competitive programming was C++, yeah. C++ is the only choice because other languages are slow. That are allowed in competitive programming. I think they don't. I think they still don't allow Rust in. There is no OCaml is just not even a choice. You cannot do OCaml when you are doing competitive programming. Like when you're actually participating in the competitions, there is a limited set of languages that you can choose from. So Rust would also not be an option. OCaml here is because I don't care about the speed. In competitive programming, it's important for your app to run fast. OCaml probably is fast enough though, so it should be able to solve most of the competitive programming problems easily. But the problem is that also the standard library matters, because how much are you writing, how much are you typing, and in OCaml the standard library is very poor, which means that it's probably a bad choice for competitive programming again, right? But C++ STL is pretty bloated, so not as bloated as Python though, for sure. So for like, I guess a couple of times in competitive programming, for example, when you do need to do big integers, you just go to the language which already has the big integers, like Python or Java. Have them in the standard library, and then you just do that instead. Is my stuff compiled? Let's try running it. Kast run test. Haha, okay. All done. All done. So this is correct. And if I do underscore underscore, it is still going to do that, right? Haha, okay. And then we do cast run. Day 10 of the advent of code. Unhandled rejection. What do you mean unhandled rejection? JavaScript also has beginned. These days, yes. Wait, I mean, I don't know. How long ago was begin introduced? Begin JavaScript. Because I was doing it like 10 years ago. More than 10 years ago, like 15 years ago is when I was doing competitive programming. I'm not even sure if JavaScript also was in the list of languages you could choose from. ...2018, yeah. They were not a thing, for sure. Okay, so... Oh, wait, no, it doesn't work, right? I was going to say that my advent of code is working, but it's not working. This error originated by throwing inside of an async function without a catch block or by rejecting a promise. The hive train was slow to appear. Handle your rejections. How do I handle my rejections? Like, where is the thing that is like? Hold on. Am I? Wait, what? I thought I could just throw an exception and that's it. In any of my. Like, I don't even see any stack trace here. Unhandled promise rejection. Is it only needed when I do the... This error originated either by throwing inside of an async function without a catch block or by rejecting a promise which was not handled with a catch, with no useful information about what function did it. The promise rejected with the reason #object. What the reason is that? That's probably just me throwing an object as an exception, right? I mean, I am throwing exceptions. I'm using exceptions for control flow, DevNinja, by the way. That's how I return from functions and like do all of these kind of things. Break from loops. Because I cannot use the return because I like create a lot of things. That's not optimal. I think the JavaScript runtime is doing it pretty well. Like if you are not creating an error, which is capturing the stack trace, but you're only I'm only creating the object, right? As you can see here, we are doing an object. This object represents basically where do I need to like go back. That's what I'm saying. Constructing the stack trace needs some time, but I'm throwing an object which does not construct a stack trace, which is probably why I'm not getting it here, right? So I'm throwing an object for unwinding. So this is like the general mechanism called unwinding. It's just an object with two fields. Is that the one though? Kast run target JavaScript examples test. Let's go back to the test. Let's try this. Unwindable block. Unwind block. Yeah, so this works. I have thrown an object and I catched it. That's how it's supposed to work. So that's not the one. Can I inspect this object like better? What is being thrown here? It just says hashtag object. You think I'm throwing a string? I mean, it says hashtag object, right? I'm rejecting a promise with a plain object and nothing is catching it. Node sees that, panics quietly, and throws the dramatic stack trace. Key clues. Hashtag object. You rejected with an object, not an error. Async functions through. Promise rejected, no catch. I'm gonna go to transpile.js and add a catch. The problem is that the transpile JavaScript is huge. Like, it's 666 kilobytes right now. Right, so where should I add the thing? Yeah, if only I was like transpiling to readable JavaScript, that would be nice. But that was not the goal, right? Why so many async awaits though? Because everything is async. Like if you think about it, what's not async? What's not await? Calculating the sum of one and not async. But I'm not tracking that information yet, right? So if I wanted to generate the JavaScript, which is either async or not async, then I need to track whether my code is actually async, right? But I'm not tracking it yet. I will track it at some point, but not yet. So because there is a possibility of something async happening, like reading the input from the std in is async, right? Technically, if you await everything, nothing is async. All right, so like the question is, does the Node.js basically like optimize this to a regular function when I'm awaiting an async function that is called immediately? Or is that the reason why I'm having the performance issues right now? Well, I don't really have much performance issues, but like my Advent of Code solutions, they should all work in under like a second, supposedly, but they are not. So I'm wondering if like all of this is actually adding the overhead. Because I don't know really how much can the Node.js optimize. It's how JS handles async stuff to so hold microtasks. Hey girl, I saw you and thought you were really cute and wanted to ask to UV and wrap you. How do you UV unwrap somebody? I mean, yeah, I understand that JavaScript handles async stuff through microtasks. The question is, like, the optimizer can optimize it because it sees that the async stuff is actually not async. That's what I'm saying, right? When it knows that it's async, it's going to be handled through microtask for sure, right? But it guarantees to be done through the microtask if it just sees that the code is actually not doing any async stuff, you know? Like, it can analyze a little bit, right? So that I don't have to optimize my JavaScript myself. All right, how do we handle unhandled promise exit rejection? How do I figure out where this is? I think this probably means, like, doesn't this mean that I have like an async function that is called without async, potentially? Should not be happening. Let's just try this. Async get set is true. Like, just to see if this changes something. It does change something. Okay, so my getters and setters are async now by changing this. So I'm calling a okay. Wait. Does this mean that I'm trying to await a not can I like await? Can I like say that f is just like this, you know, and then we just await f? No. You can await something that is not async, right? So all of the function calls can be awaited automatically. I mean, unless I want the function to return like a promise. This would mean the runtime needs to infer where actual exonericity is needed, which slows down either startup or time of the runtime. That's called JIT, right? That's what they do. They are JITting in Node.js. And they are analyzing your code. But they are not doing it immediately, but in the background while the code is still running. Right? Yes. Yes, it kicks in after the function has been run multiple times. But I'm like, I guess in the advent of code, the functions are run multiple times, a lot of times, in a hot loop. So they should be jitted, I would assume. It's not like every line is executed once. Let's see here. Async is true. Can you see any difference between this code and this code? I think there is no difference. If we rename this to body. Then this is literally equal to that. Yes. Let's remove this. So I don't want my getters and setters to be async. Let's say false. Async is. So this is when I'm creating the functions. All of the functions that we define in the Kast code are going to be async. Until I track that stuff. So this is me calling the function immediately. Impl cast add impl. Yeah. Raise error. Yeah. This over here is wrong. So this is what? What is this? What is this? I'm creating a function and I'm calling it immediately. This is a then list. Body is a statement list. Yeah. Just create a scope. Body. That's what it is. Like that. Hey, that probably was it. Async. So when I'm calling a function, then it is async. Console error is not async. That's it. Yeah, that's it. Okay, nice. So day 10 is the long day. If we do part 2, or maybe not if we do part 2. If we do part 2 on the actual input txt, right? There you go. Yes. So this Day 10 of Advent of Code is where you do Gaussian elimination. It's like Gaussian elimination is actually the fast part here, and it is solved. But then we need to go through this many combinations of free variables. So we have three free variables. We are solving like the linear equations, right? So we have three variables, and each of these variable can be at most this number. So we are doing the brute force where like we have this many combinations, right? So this is 10 to the power of 7, right? Which JavaScript should be able to handle easily. In fact, we have the transpiled JavaScript using ChatGPT, which is just running under a second. So if we transpile this properly, this should run really quickly, is what I'm saying. So I can do like node source state 10 ChatGPT transpiled part 2 input txt, right? I mean, maybe it's not transpiled properly. No, there are arguments. You need to do dash dash. Now it's trying. No. You don't need a dash dash. There is something else. Oh, you do input file and then part 1. Like it must be input txt and then part 2. No? Oh, and then input txt, like because it's not changing the directory, I think. Going to and first go to source day 10, and then I need to node. There you go, right? This is the thing. It runs instantly, not even a second. It runs in 200 milliseconds. So yeah, you see this. This is the amount of combinations. This is the last thing that we're doing. So it's just iterating, like, and stuff. This is not even the last one. There is like another one with the same number apparently, somewhere in the beginning. Yeah, I guess we're over here in the very beginning. Yeah, because not everything is async and the runtime can optimize it better, right? Yeah, I was just like hoping that the Node.js, like that the JIT is going to do the stuff for me, you know? That's what I was hoping for. I mean, it's already faster than my interpreter though, which is good. But yeah. Yeah. We need to track if something is async or not. This should be... This might just debug printing something. I'm going to undo that. Q. Undo that. Yeah. Changed something. JavaScript transpiled place. There's no effect expression. Like this did not compress the code at all, right? ChatGPT versus MyJS versus my interpreter. Yeah, my interpreter will like never finish this. When I was solving the advent of code, my interpreter was faster than it is right now because I added features, and those features they slowed down the interpreter like 1,000 times. So yeah. The reason is because the interpreter is used for compile time evaluation. The interpreter is handling inference variables and like a lot of things. Every variable is handling some inference information. There's a lot of overhead. I could do a second interpreter if I wanted, but I feel like I should for now keep the amount of backends as small as possible. So 2 backends is good enough right now. The interpreter, which is really slow, and the JavaScript. Java rewrite then. When? Never. Why would I rewrite anything in Java? Why would you ever use Java for anything? Well, except for maintaining the existing code bases. That is a valid use case for sure. That's the reason why a lot of languages are still existing. Java is a beautiful language. Most people complain about the JVM instead of the language. Well, I mean, yeah, there is a lot of limitations of the language because of the limitations of the JVM, like the way generics are implemented in Java, for example. I really don't like that. I don't remember. Like, there are. Actually have it backwards. The JVM is extraordinary piece of software. Well, I mean, yeah, I guess the limitations are not really because of the JVM, but it could be implemented differently. Like the in order to overcome the limitations of the JVM for good generics, you would need to do monomorphization, but you don't want to do monomorphization. That's like, yeah. It is the GC is like the best anywhere. Is it? They managed to make a very high level language, Java almost as fast as C. I heard they are introducing the value, like the unboxed types soon. In the Java, and I guess that involves the JVM changes too, right? JVM unboxed. Autoboxing and unboxing. I heard something about it just recently. Like value objects, right? Java's started goal is to make a language easy enough to be wielded by a new programmer. Yeah. But then there is a lot of magic happening in all of the Java frameworks, which absolutely kill the simplicity. Because there's a lot of magic done through reflection. So instead of having a statically typed language, you're basically working with something dynamically typed. Which is very similar to like my experience with the Bevy ECS in when I was doing that, for example. By usable, I mean specialization generics, for example. What do you mean specialization generics? You want to have specialization? Even Rust doesn't have specialization on stable. Does mean that Rust is unusable. All right, what are we going to do? Let's take a look at the at the JavaScript, and let's see what can I make easier. So over here, right? This await sync. So we can basically like perform this optimization ourselves. If I see that I'm calling the function that I just creating here, this can be removed, right? Does this still like are you sure that this is not detected by the Node.js? I mean, let's do it anyway because we want to see the maybe there are some JavaScript optimizers. Hold on, maybe some existing JavaScript optimizers. There's like minifiers and compressors. Are there like JavaScript optimizers which would see me calling a function that was just like that would inline function calls turn async into sync with no async actually happens? It will rarely turn async as a straight up sync call for you unless you're actually writing Rust and compiling to JavaScript. The JavaScript world would magically rip out your asynchronicity because you didn't notice it. No mainstream tool reliably does that. Babel plugins to strip async when you know there's no awaits. Like we know sometimes that the functions are wrap async and async, so it counters itself. Like you see that this async function does not have the anything, right? No, doesn't have any awaits. So we are converting this into a normal function, and whenever we call this function, but now we need to like track basically this information, right? We need to like track this information everywhere. If I'm assigning this to a variable, then I need to like make sure that the variable, like we need to have like the type system basically back here. It's not like that difficult. Like, I mean, yeah, I already created a language. We can create JavaScript from scratch, which just does some optimizations, I guess. We can like track information. Also, I'm wondering if objects are less efficient than like arrays in JavaScript. Because I'm doing a lot of the times, right? Because all of my functions in my language are taking a single argument, which like if we do multiple arguments, then we just do this, right? We have 0, 1, 2, this is just 3 arguments here of the function. Arrays are objects. Yeah, but like is this represented as a string 0, for example, in the representation, like, because this is a key, right? There is no because like this object can have the keys in like with gaps, right? But arrays, they have indices without gaps. That's the difference, you know. So the storage is different, and we don't need to do lookup. I'm assuming that they are backed by like contiguous arrays still in JavaScript when you are having arrays, but the objects are not. Is that right? Let's start by doing this simple stuff, though. Let's start by doing the simple stuff. Let's have the optimizer. Let's actually have the optimizer. Optimizer. So I'm going to open JavaScript AST, and I'm going to have the function optimize expression, which is expression into expression, and stuff, you know. Let's do that. So over here in the last step, we do AST is AST optimizer. Optimize expression. All right, let's just expression destruct. Oh wait, we don't do that. We match expression shape. Okay, undefined. We return original expression. This boolean number string. Okay, now if we say a variable, then just the original expression too. I guess the row is also original expression. Okay. Yeah. If we see a boolean, no. If we see a list, then this should be a list map optimize expression, right? So this is recursive list. Let's call this original, so we know that we are not optimizing anything. If I have a function async args body, we have function async args body. So arguments is a list of names, so there is nothing to optimize there, nothing to optimize here. I'm going to keep the asyncs for, like, I could add the tracking information here though. Maybe. If this is this like actually asynced. Like the thing is, async cannot always be optimized, right? I can check, right? But when I like when I will assign this function into a variable, I will need to now trick whether I will need to like, you know, track whether the variable contains the sync or async function now, right? Which is more work. Let's just do this later maybe. So, but body is the statement list, and this is going to be, you know, optimize statements body. So optimize statements is statement list into statement list. And when I call, so here's the simple stuff that we can do, or at least let's do optimize a single statement. For now, I'm just going to say that this is statements list map optimize statement. Okay, so over here I'm going to say function statement, function shape span as original shape destruct. So if I'm introducing a new variable, then I will just return the original. No, I will not return the original. There are some like nested stuffs here. Var value shape is let, var value is optimize expression value, assign. So on the assignment on the left hand side we have the expression. This is like a little bit of a fake, but assign a value, shape is assign, let's just keep the assigning as is for now. Value is optimize expression value. Return value is shape is return optimize expression value. Throw value is throw optimized value. Try why can I not go to the type definition here? Oh come, I'll restart. Body catch var catch body. This is going to be try body is optimize statements body catch var catch body is optimize catch body. If condition then case else case shape if condition is optimize expression condition, then case is optimize statements, else case is else case option map optimize statements. These are all optional expressions. Init, condition, and after, and then body is optimize statements. Raw is just original. Okay, what else is missing now? Object and field. No, this is object has fields. So this is going to be 28. Check, you need to check. No, hold on. What do you mean 28? You just putting random numbers in chat. 67. Shape is object, fields, list, map, line 28. Oh, this over here, yeah. This is just expression. This is going to be expression, optimize, expression, span. It's almost like this can be derived, right? Like this should be automatically written. This is just boilerplate. I would probably write a derivative if I was doing Rust in a camel. I'm not sure how. Fields, list map, optimize field, span, and optimize field is optimize object part. This should be called parts. Optimize object part into object part is function part okay. It's either unpacking of the expression, so unpack optimized expression, or it's a field with name and value. So we have field name and value is optimized value. Okay. If we say not expression, not optimize expression, then compare operator left hand side, right hand side, compare operator left hand side is optimize expression left hand side, right hand side optimize right hand side. This over here is similar, but it is a binary operator, which is different from the comparison for some reason. I should maybe like merge this into one thing. If I have a field of an object field, then we just say field object optimize expression object field is string, nothing to optimize there. Okay, and we have call. So like right now we're like kind of just doing the thing recursively without actually doing any optimizations. But when we call, like what I can do is that when we call a function that is immediately defined, then we can just replace it with the body, right? That's what we can do. Call async function and args. what I want to do. F args. Let's for now just do shape is call async. F is optimize expression f. Args is args list map optimize expression. And okay, how about I just do this f args okay, so if I'm trying to call a function, right? So we are going to see, we have the optimized expression of the function, right? We can see that this function itself is a is like immediately here, right? Then we just inline it immediately, right? And we automatically erase the asynchronous, but asynchronous must match is the only thing, right? So we say I'm going to match f with match f with so if a function itself, that's an expression. So if a function is a function literal, right, which has async is f async, args is f args, and and body, right, when async is equal to f async, I mean, this is the shape. Shape is this. You just realized something, Robert? I just realized timing is everything. So yeah, if this is a function, then we just replace this with the body, right? But the body is a statement list, so hold on. It's not like that easy. Hi, what do you mean about Java? It's a good language to learn in 26? What do you mean? I feel like this is the part where that object-oriented people would implement using the visitor pattern. Well, I mean, you don't have the ADTs, I guess, normally in your object-oriented languages, so I guess, yeah. I mean, it's not even the visitor. It's like this would be just a method on the expression, I think, is how I would do it, probably. No? Java is a good language to learn in 26. I mean, depends on your goals. Everything is good to learn if you like learning, and everything is bad to learn if you're not going. If your goal is not learning, you know, like sometimes learning is bad because it can distract you from like things. Java runs on every platform. Yeah, on billion devices, right? How many billion devices is it these days? But probably JavaScript is the better language to learn. Like, if you're learning programming, I'm assuming, if you're asking the question whether Java is a good language to learn, you're probably just learning programming. So I just always suggest the most popular one, which is JavaScript. And then go from there. Unless you're specifically targeting a Java job, I don't think learning Java is very useful. Is there any difference in JavaScript, by the way, in terms of like performance? When we see, when I see a function that returns a value versus a function that returns the value like this, is this any different? Is there any difference if I use the function versus the lambda syntax? Probably not, right? So this should not matter in terms of performance at all, right? Okay, yeah. Like, since this is an expression, if there is actually multiple statements here, then I must keep this as a statements. So the only like if this body is multiple statements, right? But if I'm returning an expression immediately, right? So if a body is a single thing, which is return body, basically, you know? In that case, in this case, we can replace it with the body. But inside of the body, we need to replace all of the names with my arguments. But I need to assign it to the arguments first, though, right? Because my arguments are expressions. Belarus. Started to learn Java 2 years ago. I left programming. Sorry for bad English. No problem. Like, what am I supposed to do here? I feel like it's easier to start if we see it in a statement, you know? Let's do this over here first. So if I have a statement, and a statement is an expression, so this statement may basically be converted into multiple statements, I think. So then over here we will flatten. So because statement can be converted into multiple statements, right? That makes sense. Because we're going to inline a function. So over here, I have an expression. First, I'm going to optimize it, right? First, I'm going to optimize it, and then we're going to see. So let expression is optimize expression. And then we are going to match expression. If the expression is a call, and so this call async, arguments is call arguments, and then function. And then if we try to call a function, which is itself function, so if we have yeah, something like that. Function async is function f async args body. And then we do this when call async is equal to the boolean async only. Dun, dun. So in this case, we can replace with the body here directly, right? Yeah. So we are going to say body, but before body, I will need to assign the arguments to the function arguments, right? Yeah. So we'll need to do f args list map function argument. No, we need to do zip, right? Is there a zip? Is there no zipping in OCaml? It's probably called something else. I have my own zip. Oh, it's called combine. That's what it's called. So I'm going to zip function args and call args, and then we're going to map the function arg and call arg, and we're going to create a let variable is function argument and value is call argument, right? So instead of giving the function arguments like this, we're going to just introduce the new variables. Where's the syntax error? This must be in parentheses. Yo, just Covino. Thank you for the read. Hi. How are you doing? I was told that you have made like 1 billion games in 1 month recently. Is that true? I have created 0 games in the last year. So, but hopefully it's going to change soon. I'm going to continue working on my Link Cider game. But for now, I'm stuck. I'm making my own programming language. But yeah, there was a time where I was participating in a bunch of game jams too. We are going to... The goal here, I'm making a programming language, and I'm going to like transpile it to JavaScript, which I'm already doing, and I'm going to create a game engine with it, and then I'm going to use it to do game jams. Yes, yes, yes. What do you mean, oh no? I thought oh no in Pigorli language just means hello, because I don't know. Every time I join somebody's chat and Pigorli is there, I see an oh no. All right. Here's what my current JavaScript that I'm generating looks like, and I'm trying to optimize it because this is not very efficient. So yeah, we're going to like, I'm creating a function here and then I'm calling it immediately. So we're going to replace all of that with just this. And then we're going to like do a bunch of optimizations. That's the idea, and that's what I'm working on right now. When translated from Pigorli speak, it means OMG, I'm so excited to see insert person name here. Yep. Exactly. Alright. What are you working on right now? You're doing more game jams, or do you have a like a game that you're working on, like the big game? Or you're just doing like a bunch of small ones? So I was doing myself a bunch of these game jams. That's how a Linksider started. It was made for a game jam, but now we're I want to say we're working on it, but like it's been almost a year now that I have not worked on my game. But we have a demo on Steam and we're going to release it this year for sure. For sure. That's not true. Just small games right now, trying to learn how to program and game dev. Yeah, I see. Nice. Multiplayer, capture the flag. You streamed it in fall winter last year. Yeah, that's why I'm saying almost a year ago. I worked on it last time. So yeah. The plan was to return to it in January. I'm just waiting on my teammates. Because I'm not making a game solo. So it's kind of nice if everyone is working on the game, you know? Oh, I started in fall, winter last year. How was it maxed? 4 or 5 months? Last year, winter is a year ago, right? I don't remember doing it in fall, though. Was it? Did I do that? I mean, maybe it's not a year then. Maybe it's just half a year. December? Alright, my memory is bad, I guess. I thought I was doing Kast all of the December. It was Advent of Code. I'm pretty sure I was not doing it in December. Okay, so we'll let every function argument be every call argument, and then we just do the body, right? Like that. Let's see how much this optimizes already. So right now we have 659 kilobytes. Do you think 630 kilobytes? I stripped like 29 kilobytes. Something happened. So this over here is an expression, but so in this case, because it's an expression, I cannot optimize it away. Rip what? It didn't say the username. It did say Pigorli. Maybe I was too loud. Yeah, I did hear something like Pigorli being said by TTS.
Devnunya.
Yeah, it only says your message, not your name. Did they fix it? I don't know. Maybe it depends on the... maybe it's like a different voice, because I think I have different voices for different, like, things. Like, can you try a hello?
Hello Dev 9-inch nails ya. Hello Koovy man.
Yes. It's different voices, which are doing different pronunciation. Apparently. I feel like, you know, in order to optimize this properly, we need to, like, basically convert this into, like, a variable first, and then assign it to a field. Then we will be able to optimize it. Maybe? I don't know. Do you think I already did some performance improvements? Wait a second. Wait a second. It's quitting immediately. I think it means that it's not correct. It's faster. Why is it quitting immediately, though? That makes no sense. Let's try not optimizing. Yes. So I optimized away the entire code. This is the only actual optimization that's happening. When false, and this. Okay. This still works. So this optimization is not correct? Wait, what? Why not? So I'm calling a function that is defined right here. You can submit your result there, no code. Well, I mean, there was some code. Why? Hold on. What's wrong here? So if I'm trying to call a function with this body, with these arguments, using these arguments, so both the call is awaiting and the function is async. And we just go over the function arguments, and we are assigning the function argument to the call argument. And after that, we just do the body. I don't see a bug here. This is correct code, right? Maybe... No, there's no... No. I'm doing a let, so it would complain if I created a variable, right? Of the same name. Although, like, I'm generating the names separately, so maybe you need a debugger for a camel right now. Doesn't work. I mean, what would I do with the debugger, though? See, like, put a breakpoint here and see what's up. What's my expression? And what's my result? But this is called it multiple times. So maybe, like, some of them are correct and some of them are not for some reason. Print out both original and result. Yes, printing is also not very easy, you know, in a camel, because printing is like difficult. Unless we actually do the debugging. But I mean, yeah, like I'm like, you know, result is this result, right? Like if I do a breakpoint over here, I guess, right? So we can see what result is and what the expression is, right? Also, we like in this case, optimize expression, right? We can say optimize expression as statement. So like, because in this case, it can be a statement. I can move this in another place. Right. Optimize expression as statements. Expression. Yep, that's what I want. And optimize expression as statements. Expression statement list. Function expression. Maybe I should just take a look at the very beginning of the code. Wait, yeah, this is async function that is just being called. Whatever. These are some values. Values. Surely group them into a single object. Unless creating an object is like having performance overhead, which it probably does. Okay, well, there's a lot of code. But where's the actual code of the thing? Machine, okay, that is us. Assert answers. Okay, assert answers means that this is yeah, over here, the change directory. So I'm doing the change directory. Wasn't there a decollapse all? Yeah, maybe. Like, is this... Hold on, sys change directory. And then we call that using the dir name of that, right? Yeah. Can I go here and debug? How do I debug? Like, start debugging just launches what? The debugger. I mean, I have a launch JSON, which is like, this is the thing that's going to be launched, right? It debugging Kast, so it's transpiling current file to JavaScript, and then it runs that through Node. But how do I run the JavaScript? How do I debug this file? Like, there's multiple debuggers that we can launch. Where is the select menu? Or is it like launch? Open launch JSON? No. You would create another launch config. I'm pretty sure there is a way to do it without creating it. Right? Like, for example, when you do run build task, that it's initial, that's like giving me all of the different ways that all of the any of the extension can do it. Yeah, I know that there can be an entry, but like I'm pretty sure that you can do it without even doing anything in the launch JSON. You can just like debug the current file, you know? Somehow there is a button somewhere. I cannot find it. How to launch and debug current JavaScript file with Node without editing launch JSON. There's a way to do it. I already have launch JSON, and it and F5 runs the thing from there instead. Debug current file, right? Like that should be the thing. Debug current file. But there is no debug current file. Debug tests in the current file, but not the current file. Oh, maybe it's node. Debug attached to node process. Hallucination. Like, I know that there is a command there. I have seen it before. I just don't remember what it is. JavaScript. Debug. JavaScript debug terminal. I don't know what that did. Select debug session. Select and start debugging. Okay, there you go. Why is it so difficult to find? Run current file. Wait, what? This is from Kast. I don't want the Kast. Hello? This is stupid. There we go. This actually did it. Right? Okay, breakpoints. But I never... Wait, is it still running? No, it's not running anymore, right? Okay, let's try going here. Right? Yeah. Like, I can't do it. I did not add anything to the launch JSON. But why is it so difficult to do this? I mean, let's just step over everything, maybe. Okay, it exited already. I did have 10. I was supposed to step over, right? Collapse all is from the search. That's different. Collapse all. Fold. Fold all is the thing. But now I don't see anything. I guess this is what I need to figure out. Am I getting here? That's the question. If I do F5, that's going to do this, yes. Step over just exits the thing. Or something. So I'm getting here. Am I getting here? I am. Okay, let's see here. So these are just captured like things that are required, like from the standard library. Over here, this is my Gauss. No, this is just constants that I use in my code. And the actual code is like over here somewhere. Yeah, this over here is the actual code. So I'm getting here, and we are supposed to go inside of this code, right? I am getting inside. And then inside of this, try loop. What is this loop? Oh, this is for the arguments. Forget about that. Part 2, assert answers. Like I'm getting... Wait, this is hollow. What? Unbound breakpoints. This code is like not even going to be... What? That makes no sense. So like this code is okay. Why is the breakpoint acting so weird? I'm clicking over here and it's placing the breakpoint over there. What? Is that normal for JavaScript? And this just added another breakpoint on this line too, like, but in the middle now? What? Alright, I'm not sure if the debugger is the way. We just need to print something. Maybe I should just, you know, we should just run something else. Kast run target JavaScript. Let's run the example. Hello world. How about that? Hello world is still working. Okay. What about guess a number? Guess a number still works. Wait. Oh, okay. Over here. I see the issue, I guess. So I'm guessing less, and then we're not continuing the loop, I guess. Is the loops not working? Oh, that makes no sense. One thing that we can do, you know, we should let's create the formatted thing. Right? So this exits immediately. I'm just going to copy target compiled into target compiled no optimizations. And then I'm going to... Oh, wait, this is optimized, actually. Optimized. And then we're going to do this. Right, so this one works properly. Let's do diff compiled and optimized. Right? How big is the diff? It's pretty big, right? So yeah, as you can see over here, we had a function call and we replaced it with the body of the function. That makes sense. And then let us go from the bottom, I guess. So over here I had a function call. It is just... So this function call is completely removed. We'll replace it with this throw. E. Yeah, we catch that. That's like my function body. That makes sense. Is there like a simpler function call? Maybe... Maybe I just need to rest, you know? I have been streaming for 7 hours. I'm just staring at things without understanding what's wrong. I also like, maybe like in order to do the optimizations, so right now we're representing the JavaScript AST as either like an expression or a statement, but that's not very useful. Maybe. I don't know. Like, because so like the thing that I'm trying to optimize is basically converting an expression which has statements like so in Kast we just say something like this, you know, like call a function and return x, right? So this is a block which returns a value. This is not possible to do in JavaScript. So we instead convert this to a function that returns the last thing, and then we call this function immediately, right? And now I want to undo that. What if I just generate something different in in the beginning? What if I just don't generate these functions that we are calling immediately? That would be better. Yeah, but how do you do this? So like, basically when you're compiling, so I'm compiling an expression. Compiling an expression basically has, I guess, so like compiling an expression has side effects plus the pure expression, which represents the value after the side effects are done. I guess like that is like what my transpiler should do, you know. So when we see this over here is just the side effect, and this last thing we like calculate it, right? So this over here, I don't know, like 2 plus 2, right? So we assign this to a thing, right? So that result is 2 plus 2. And now we know that the result of our expression is here. And so we would be able to use it somewhere. So let's say that I am now this over here is an expression that is also I guess it doesn't even need to be pure, like but sometimes we want like statement list, right? Plus the final expression, right? So we evaluate something like a bunch of statements, and then we actually have the expression, the final expression. So right now I just convert the statements into an expression by creating a function and invoking it immediately, right? But we could do this instead. What would that mean? So let's just actually try this real quick. Let me just make sure that everything works right now. This is disabled, right? So this stuff should work. Yeah, seems like it's working. JavaScript optimizer beginnings. I'm just going to keep this here. Let's go back to transpiler. So right now, when I say transpile expression, right? So I have two functions. I have transpile expression and transpile expression as statements, where we don't care about the result, but we should actually just have a single function which has transpile expression. It returns like the expression plus the thing. What is that? f2 plus 2. I mean, yeah. Yeah, we can like do that stuff too. You're right. But I think like in general, so we don't just return a JavaScript expression, we return a list of statements. And the expression, right? So when I have a value, transpile value, values, I guess, can also be the same, right? Maybe this should just be like, you know, transpiled, like code. So the code in general, I guess I can call it transpiled expression. It has a like statements followed by the expression which holds the value, which we are evaluating basically, right? In a language where everything is an expression. Does that make sense? So for example, over here we have a function. I try to call it scope or block, which only has a list of statements. But it doesn't have a list of statements, it has a value. Which is an expression, right? We can do it like you showed, or we can just like use this in line instead of assigning it to a variable. Like maybe we don't need to assign it to a variable, you know, and we can just inline it in the later thing. In Kast, yes. In JavaScript, no. Well, that's what I'm calling it, transpiled, right? Because this can, like, I don't even necessarily need to create a scope, you know. So this is just this is what we transpile our expressions into. That's all, you know. So expression, when transpiled, can be converted into the transpiled expression, which is statements followed by the actual expression in JavaScript. You know, and then with this expression we can assign it to a value like you showed, or we can inline it in like the future stuff. That makes sense, right? So transpile value, I think this also should just be transpiled expression. Transpiled expression. So claim transpiled expression, read place. This returns no effect expression. Okay, let's return statement is empty, expression is result. Okay. Does match. So like everything that is like JavaScript exception is usually just going to be transpiled expression instead. Assign to place, transpiled expression. So I don't even return. No, we don't. Yeah. This is literally just a list of statements because we don't have a value. And in this case, we care about the value. In this case, we don't care about the value, so we just have the statement list, right? Place set. Place set. So this is going to be like transpiled expression. This is going to be a huge thing. I should just go and stop for now, but whatever. Let's see if I can do it quickly here. We just go focus mode. Claim returns transpiled expressions, right? I feel like, you know what? What if we have our scope in like the context here? So that, like, you know, we are just going to append to the current scope the statement instead of like handling these values here directly, you know? Which means that we will still just be able to return like the transpiled place here. But then we will have another context which has the current scope, you know, like scope statement list mutable. Maybe a little weird, I don't know. Let's have it as a separate thing. Let scope type scope is mutable statements is statement list, and we have like, yeah, basically what I want is I want to like append the statement to the current scope that we are in. So let execute basically is what we want. Statement is execute all statements is, we're going to have like effect get scope. So execute all statements is going to be let scope be effect perform get scope, and scope statements appended with scope with the statements like this. Okay. Place set transpiled expression. So yes, we now don't have the transpiled expression. We return normal expression, just like before. You know. And we instead use the effect system and like append this stuff, you know. And then we don't have this ugly thing too. So over here. Variable. This variable is not used even. So these statements, we're just going to execute basically them in the current scope, I guess. That's, wait, hold on. This is not because if I return the expression, it means that we need to preserve the order of execution, though, right? Which is why I wanted the results then to always be pure. Is there overhead to creating a variable in JavaScript? Can the variables be inlined? Is there what? The overhead in creating a variable. Instead of like saying let x is equal to 2, if I instead say let 2 be equal to 2 and then let x be equal to like that variable that we had before. So we have an extra variable for no reason, you know? Is that going to be optimized the way or not? So transpile expression of statements, like we are going to actually merge the function then, and we are going to have a single function called transpile expression, supposedly, right? And we just return place here. This does not have statements, and we just claim the place. If we have a then, so like this scope, so yeah, we had this scope, right, which has a statement list. This was returning the expression, though this is where we call the function that we were creating. Let's just not create it at all. Let's call this scope 2 and then make sure that's not used. So over here we have a then, right? A then expression is just evaluating these expressions. Right? Yeah. Yeah. Yeah, I feel like this should return no effects. Let's just make sure that is what we do. Just place to JS. Claim place. So like claim place is going to return no effect expression, but it's going to potentially execute some code later. Transpile value. Let's call calculate. Calculate this. So calculate is JavaScript expression into no effect expression, right? So this is going to be like this. We're going to execute. We're going to create a variable name, right? So variable name is generate name. variable, whatever, right? And then we're going to execute let var value is equal to expression value. So this is function value, right? And then we just return no effect variable like this. So yeah, whenever we calculate an expression, we execute this for the side effect, and now we have the pure expression, which is the variable name. Basically, that's all for the actual value that we care about, right? Yeah. That makes sense, right? Maybe calculate should always just return a variable name then? Like, that's literally what you said here, right? In your example, right? This result, right? You create the new variable name here. And then you assign to it. So maybe no effect expression is literally just a variable. But I mean, maybe let's keep it no effect expression for now. So over here we have a then, only the last expression matters. Right? So we do let statements, I guess statements and expression is list last. I want to like split the last one and get like the other list, you know? We can, I don't know, let's try list iterate, right? Let expression be none. And then we say that expression is some function e, like that. But then I say that match expression with none, but nothing, with some expression. So this now turns into a statement basically, and then we do something with that. So if this is a statement, then we just execute it for the side effects, you know, in this list. So can I just basically execute? Well, I mean, I will transpile expression statement, right? This gives me the no effect expression in the result. So we just do that. Right? Let no effect be this. So this transpilation is going to execute the side effect. And that is all that we need. And then in the end, right? So then in the end, I'm going to match expression with so none, then we return the no effect shape is undefined, I guess. If I did not have anything, then we will have undefined. But if I had some expression, then we say Then we say just transpile expression in the end. And then this is something that we don't need to do anymore. Okay, right? If I have a statement, so if I have a statement expression, this means that we're just discarding the result. So we're going to just say that let no effect underscore be transpile expression. And then we just return no effect undefined. So over here, I'm creating a scope, right? So when I create a scope, we actually created a JavaScript scope now explicitly instead of creating a bunch of scopes everywhere. I'm actually going to create a scope here. So I'm going to say try with effect get scope. Okay. Effect continue k scope. And then over here, I actually create this scope, right? So scope is wait, I don't care about the scopes. I don't care about creating the scopes. The only scopes that we create is like when we have a function. Forget about that. Forget about it. So yeah, function should return not this, but no effect. What about the root scope? Yeah, we are going to create the root scope, and then for every function a scope, right? That's all. Because those are the scopes that we need. We're not going to create like the actual scope blocks, which are like corresponding to the cast scope blocks. Because we just like evaluate them as expression, like because scopes in cast are just. I mean, they yeah. We'll see. We'll see. Maybe I will have to. Because there is something like that at the end of the scope, like the context no longer apply. I'm not sure how we are going to have like the drop semantics. If I'm probably just going to have it. We'll see. Even Rust creates a new scope for statement. Well, I mean, scopes, they have like semantics, right? They're not just like parentheses. Let's have a to do here. To do JS scope question mark. Fine, I will keep that here. But like it's basically like parentheses when you're calculating 2 plus 2 plus 2 and you like one of the 2 plus 2's is inside of parentheses. That's the scope basically. Scope is just parentheses. For the most part. Anywhere. Right? With the exception of like the drop semantics, I guess. And the context semantics. So I will probably need to do that. But I don't have the drop implemented yet anyway. So, and maybe like the drop is going to emit the into this expression, the drop like code is already going to be there. Okay, when I have a tuple, I say calculate the object. Value is okay. Okay, pure Transpile. Let's also have this. So we have calculate, which is this direction, and we also have pure. Pure is the other direction. We have no effect expression, which we can call probably pure expression, right? Into JavaScript st expression. Function, no effect, expression. You can use the new modern using keyword, using foo is stuff. If foo goes out of scope, the symbol dispose method will be called an object. Yeah, maybe later. Like I don't have it. I need to like make sure that it's in the interpreter first too. Yeah. Also, it's not always when it goes out of scope, I guess, because the move semantics, just like in Rust, can move like we can move something into like another function or whatever, and then the drop is not going to be called actually. But at the same time, we can do it similar to the C++ move semantics, where moving actually still leaves the original object in the usable state, where the drop implementation is going to be a no-op, I guess. That is also a possibility. But I'm not thinking about it yet too much. Okay, so over here we say calculate the call function and arguments. So over here though, we have a problem in the because OCaml doesn't specify the order of evaluation of the arguments and stuff. So I'd say that function is this, because we now care about the order of evaluation. So we first calculate the function, then we will calculate the arguments, and then we call with a single argument this thing. Instantiation generic is going to be the same. Dun, 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 dun. Assigning. So this is now in the transpile expression of statements. Let's forget about this for now. Calculate. Well, I mean, this actually is already pure, you know? This is already pure. No, this is like no effects, basically. Because this is null. New type, no effect. Null. Raw, this is going to be calculate. Expression module. So first we introduce the module, right? So we execute this, which is let module var is the object, an empty object. And then we transpile expression definition, and then we are going to ignore it, the result of it. It's going to be ignored. And we have no effect variable module var as our result. Okay, I think this is going to be nice. Like, I'm basically like, I say execute, right? But this actually emits the execution. Like, it's almost like I'm writing an interpreter. I'm wondering if I can you know, create an abstract interpreter. Because I feel like it's almost should be like the same code. You know? So in the interpreter, this is the evaluate expression, basically. So which results in a value, but in a JavaScript we result in like the reference to a value, JavaScript. Yeah. I'll think about it. I'm not going to do this refactor right now, though. So yeah, when we have an if, and we have the result, right? We need to create a variable. So I need to like introduce a variable here, or use a ternary operator. If we want this to be an expression. So I don't return. I just execute the if here, right? But what do I return? So it means that the result of the if must be stored in a variable. So say let var be generate name var, right? So instead of returning, we are just going to do the something. Yeah, okay, but now inside of the then case we have its own like thing, you know? Yeah, now this is inside of its own scope. So I need to create the scope here. So maybe I should have a function scope, which and function scope should be a function. Let's call it with scope because whatever, scope. So scope is a function, and inside of this function I'm just so scope will return the list of statements, I guess. Yeah, and inside over here I can just execute a bunch of things. So I'm just going to execute here shape is just let var. No, it's not let now, it must be assign, where assignee is var execute assign var transpiled expression then case. I like that. And over here in the else case we say scope assign var transpile expression else case. scope is having a function and returns the statement list. So this is where I'm trying to call this function with effect get scope k effect continue a scope. Scope is statements is empty. And after try, I need to return scope statements. That's all basically. And what else was there? Like assign var has a var which is a name. And value, which is going to be a pure expression. So this is just going to execute assign assigning is var value. It's pure value. Yeah, let's do that. Okay, so when I have assign expression, yeah, okay. Expression assign. Let's finish the if first. Transpile expression. Condition. Test. Condition is pure condition. ArrayLib has camera move forward and camera move right, but no movement function to left and backward. Interesting. Are you imagining? Oh, I am. Expression match. Let's do assign first. Assign. Or let's do transpile expression as statements. Let's do this one real quick. Okay, so assign is not doing the statement list. This is just returning unit because we're using the effect here to generate the statements, right? So we literally just say assign, assignee, place. That's all. And assignment is like returning nothing, right? So I should probably just do like undefined, you know. Like over here, this is undefined, and undefined is no effect, shape span is none, undefined. Yeah, okay, pattern matching. I feel like I'm rewriting everything from scratch here. But okay. And I stream for 8 hours. And it's 4:20 a.m. for me right now. Sometimes they're bigger, some smaller. Yeah. There are... this one can be done like in just like almost couple hours. There was the other one which took me several days before and multiple different attempts where I was discarding the a lot of work. All right, let's see here. So say so matched place is this, right? Matched place is this. This is transpiled place. Okay, so I can just execute this thing. I just let let variable, which is the matched variable, with this matched placed from var. Oh wait, but now transpiled place expression has I can have like the effects, right? This is actually good. So place expressions are also pure. So I mean places are pure, right? Transpiled place. It's a pure one. So set is just going to actually do the unit, because we're going to execute it instead. Place to JS. So over here we have a function, and this is a scope, which means that place to JS must be in my recursive group here. Can I have like all of these? And moved. Hold on. And all of these things must be moved over here. Place of no effect expression is so set is function value into, so here we just execute the assignment basically. That's all. Assign is pure expression. Okay, and then over here, when we convert to the JavaScript, the set field is going to be place set. Yeah, this is going to be like scope, in which inside of which we are setting. So yeah. To do expression. To do expression. This returns an expression. Can I just say to do? There is a to do statement and then there is a to do. Can I just say to do? Which is going to return unit. So which is going to raise error. And raise error is just going to execute this. Then. To do expression. We don't have to do expression anymore. So over here, when I compile in a function, I'm going to create a scope here. Oh, I guess the body. The body of the function is the scope. Is the new scope with this stuff. Where so basically we first do pattern match. And then we just transpile expression body. And then we return the result, right? So pattern matching. So pattern matching is another thing. This should return also unit. We'll literally pretend that it's evaluating. So we're doing the pattern matching. Then we say that result is transpile expression body. And then in the end we just execute return result. Like that. Expected type is no effect expression. That's right. Yeah, so I create a function here. I'm just going to, I guess, Wait, does it mean that every time I create a function, I'm going to assign it to the new variable first? Sure. Sure. Assign var and calculate this thing. So we'll say var is gen name function. Okay. Wait, assign var should return unit. So we are returning the var. Well, I mean, I'm calculating the function though. Hold on. Right? Yeah, let's not do that. We are just returning the calculated function. There we go. That's all. Transpile value. Value. I guess value is also going to be just expression. Or should we do prepend? But we don't, because instead, so I don't need to prepend anymore, I think. I mean, we have the variable, so we say like no effect variable here. Well, I mean, I can prepend to whatever. Yeah, because this is the one is global, sure. Transpile value shape is the same. No effect expression. So over here, say value shape, transpile value shape. Let this be that. Okay, but I didn't need to not prepend though, right? I need to not prepend though, because I just need to do this in the global scope with global scope. With global scope, we just are going to execute let like this, and with global scope is with global scope is basically the prepending, right? Thing f is just going to be let's just say prepend scope f, right? That's what we do. Transpile value shape. This one just don't have any effects. This one does not have any effects, which means that we can inline these things. number. This one doesn't have any effects. This one doesn't have any effects. I can always also calculate. So that the strings are only like appearing once. Not sure if the numbers make sense to deduplicate. Definitely not the booleans, I think. Maybe this is where, like, I'm looking up the variables by name. Like, is that having any overhead in JavaScript? Looking up names? Probably, right? Value tuple. So this is just calculating. Transpile type. Of expression. This is basically like the value. Not inferred. Huh. Primitive. No effect. Assign to place. If I have a camel, this... Yeah, so assigning to place is just a unit. We are assigning any expression. Sure. Sure. Place, space, shape. So this is just going to be executed, right? Here. Yeah, that makes sense. Does match. So does match. It returns a boolean, I guess. So this also should return a pure and no effect expression, which is going to be a boolean, right? So this is a boolean true, unit true, binding true. If I have a tuple, so now I don't do the scopes here anymore. I just go parts list map. Oh wait, but I can return early here is the thing, right? I cannot return early from a random block in the thing. So in this case, I will have to do it with a scope. Huh? Should I? Will I? So basically, I'm trying to pattern match against the tuple. So what we're doing here is we're checking that every part of the tuple pattern matches recursively, right? But I can return early if one of the parts don't match. So yeah, this should be done with a function. It just feels weird. I mean, oh, wait, hold on. We can break. We can do a break. We can do a loop. Because that's what we're doing, right? We're going to do a loop. That's right. So we're going to create var is generate name matches, right? So then we go over, we basically go over the parts. We're going to create a loop here, right? We're going to execute. Shape is 4. Span. Shape is 4. This is wrong, Ocaml. For init. Okay, yes. So in initialization, wait, but what I like, hold on, what? It's not a loop, because it's a static loop. We're iterating over statically known things. Can you break out of a block in JavaScript? Maybe there is in modern JavaScript. Can you break out of a block in JavaScript? Yes and no. A plain block, totally fake. You can break out of it. This is illegal. We have labeled blocks. Okay, is a labeled block a thing? Labeled block JS. Labeled statement. Block statement. Widely available since 2015. Yeah, so we can break loop, right? And when we create a scope, that also is basically like a statement. We can have any statement basically, right? They just give us examples for loops here, but it's not necessarily a loop. Interesting. So we are going to execute a labeled thing with the label being pattern match, I guess. Can I shadow the labels though? That's what I'm wondering also in JavaScript then. So can I have in JavaScript label A, right? And then we can break A, right? That's what we can do. And what if I have inside here A, break A, duplicate label. Okay, so yeah, I need to like create a new one. It's not really a big deal, I guess. So labels can be names. We just say JavaScript SD generate name match matches. Sure. Yeah. So we have labeled statement, which is a block, I guess. We can have any anything. So statement in this case is going to be a block, where body is like the scope, right? Body. Yes, something like that. So I need to create a new thing. This. So I have a new statement, two statement shapes, a block of statement list, or we have the labeled of label name and statement, and we should also have the break, right? I'm not using breaks yet, but we should basically be able to break of optional label of break. Let's call this labeled break. Labeled label statement. We're just going to print name label writer right. So label double colon and then the statement, right? Right? Oh, it's print statement. Okay. Then we have a block statement. This is going to be oh, we don't do that. Writer is here. Of course it's here because it's whatever. So for a block we just write the opening and then we're going to write the closing curly bracket. And in the middle we're going to write print statement. Writer statements. And then we have the labeled break. Label. And then we just writer write break. And writer and print name writer label. Okay, there we go. Now we can generate those. When we're doing a does match, we do this: execute labeled statement. We have a label statement is block body, right? And then in the end, we are going to return no effect, shape is var span none. Okay. And then body is a scope in which we are going to iterate over the parts. So originally we say that matches is true, but then yeah. So we just say execute, or I guess we do assign var we assign true to it. But then we are going to assign false if something doesn't match. So we only do the fields for now. So this is an if, which we are going to execute. What is this a statement? This should be unit. There we go. So we execute an if. Where condition is calculate this does match this, then case is return. So we don't return now, we instead labeled break, right? Labeled break from the label, that's all. But before breaking from the label, this should be like match label, matches label, matches label, label, matches label. But before breaking, we need to like assign to a variable, right? Let's just do scope here. So we are just going to execute this. We're just going to execute the break, and then we're going to assign to a variable. We're going to assign no effect boolean false, so it doesn't match. Like that. Execute. And then matching a variant. So I just need to do execute these, and then we execute this. We have an if. Mm. So I execute an if, which says that if it's equal, the variant tag, if that's equal to the symbol for the label, if value tag is equal to this, then we need to do the this thing. Else we return false. So don't I just say we assign to false first? In this case, we assign the matches to false. But then if it actually matched the tag, in this case, we do this, and then I'm going to assign var we have an if, right? Where else case is just going to be none in this case, because we're already assigned it to false first. But then case is just going to be a scope in which well, we now have a value pattern, right? Yeah, so we're going to match value pattern here. If it is none, then we so in any case, I'm going to right. We need to assign var matches effect shape is boolean, so it just matches if we don't have any value pattern, right? But if we do have a value pattern, then we are going to assign var matches whether this thing matches actually, like that. And this is going to be value data. Pattern match. I thought I was like getting close to done, but like there's still half of the file read. I guess this is also one of those that is going to take multiple days. Because I just started it very late. I think we're just going to go and rest. Alright. Thank you guys for watching. I will continue. I might do this thing off stream though, right? Like I'm just we already have a working transpiler. I'm just like refactoring it. And by the way, like so the funny thing about this refactor that I'm doing, like I think here's the important part. So pattern match is now an effectful function. We have a pattern, and what we are pattern matching against, which is a place, right? This is very similar to the actual interpreter and how the interpreter works, right? So it's just like the effect of the pattern matching is introducing the variables in the JavaScript output in this case, but in the case of the interpreter, the effect of the pattern matching is actually introducing the variables in the the interpreter. So I feel like this code could be written in a way where the interpreter and the JavaScript transpiler actually share the code, but we switch the backend, you know? So we create an abstract interpreter or something. Something. I'm not exactly sure how it can work, but the code is very similar. So yeah. See you guys next time. Thank you for watching. Bye.